Hello there and welcome to Just About Earth, where curiosity gets comfortable and science is allowed to slow down a little. Tonight we're stepping into one of those ideas that sounds ridiculous at first, troubling a few seconds later, and strangely difficult to forget once it has settled into your mind. It is the thought that you may be immortal, but not in the dramatic storybook sense, not with glowing eyes, not with a cape, not with the inconvenience of living forever in a castle full of dust and poor lighting. Something much odder than that. Something quieter. Something hidden inside modern physics, or at least inside one interpretation of it. Before we get there though, I'd love to know where you're listening from tonight, and what time it is in your part of the world. There is something fitting about asking that at the beginning of a story like this, because our subject has a great deal to do with where you happen to be, what version of events you happen to be moving through, and how many other ways things may have gone. And if this gentle little expedition turns out to be your kind of thing, if you enjoy having your sense of reality rearranged in the calmest way possible, do consider liking the video, subscribing and staying a while. It helps this corner of the universe find other people who are also awake at odd hours wondering whether existence is a bit more complicated than advertised, which, to be fair, it usually is. Now settle in for a moment, because the claim in front of us is not simple, and it is certainly not settled science. It is a speculative idea built from real physics, real philosophy, and a very human discomfort with the notion of not being here anymore. We're not talking about a proven law of nature. We're talking about a possibility that emerges if a particular way of understanding quantum mechanics is taken seriously all the way to its unsettling edge. Most of us, at some point, have tried to imagine our own absence and failed. We can picture an empty room. We can picture a world that keeps going without us, traffic still moving, kettle still boiling, someone somewhere still replying to an email a bit too late. We can imagine our name being spoken in the past tense. But the actual experience of not existing is something the mind never quite manages to grasp. Every attempt to imagine it quietly sneaks an observer back into the scene. There you are looking at the empty room. There you are standing outside your own story, somehow still present in order to think about not being present. Consciousness is annoyingly difficult to remove from its own thought experiments. It keeps turning up like an actor who refuses to leave the stage. That little failure of imagination is where tonight's idea begins to feel uncomfortably persuasive. If experience always has to be experienced by someone, then from your own point of view, can you ever reach a moment in which you're simply not there? Common sense says, of course you can. Biology says, of course you can. History is full of examples. Every cemetery gives the same reply. And yet quantum immortality comes along and says, yes, perhaps in the ordinary sense people do die. Constantly, tragically, unavoidably. But if reality branches, and if every quantum outcome really does occur in some branch of the universe, then perhaps there is always some branch in which your conscious experience continues. Not because you are protected, not because fate has chosen you, not because the universe is sentimental, simply because in branches where you do not survive, there is no version of you left to notice. Already this starts to sound less like science, and more like the kind of conversation that takes place at 1 a.m, when someone says, "Hear me out," and everyone else immediately becomes nervous. Fair enough. But the strange thing is that the path to this idea does not begin with mysticism. It begins with one of the most successful scientific theories ever developed. Quantum mechanics has been tested to absurd precision. It gives us semiconductors, lasers, MRI machines, and a long list of technologies that make modern life possible, or at least make it possible to misplace your phone with much greater efficiency. The problem is not that quantum mechanics fails. The problem is that it works so well while remaining deeply weird. At its core, it describes the world in terms of probabilities, superpositions and measurements that seem to force reality into one outcome or another. A particle can be described as occupying multiple possible states at once until something like an observation takes place. Then one definite result appears. That word observation, by the way, has caused enough confusion to keep generations of philosophers happily employed. It does not necessarily mean that a human eyeball must be present, peering nobly into a microscope. It means an interaction that produces a definite outcome, something that entangles the system with the wider world. Still, the puzzle remains. Before measurement, the math gives us a spread of possibilities. After measurement, we experience one actual result. Why that one? What happened to the others? Did they vanish? Were they never real? Did the act of measurement somehow collapse the wave function into a single world? For much of the 20th century, the standard classroom answer leaned in that direction. The wave function gives probabilities, then measurement yields one observed reality, and we politely avoid asking too many rude questions about what exactly counts as measurement or why nature should suddenly behave in two such different ways. Some physicists were not satisfied with that arrangement. One of them was Hugh Everett III, a young American physicist who in the 1950s looked at the whole business and suggested, in essence, that perhaps the problem was not with the quantum math at all. Perhaps the problem was with our insistence that only one outcome becomes real. Everett proposed something much more drastic. Maybe the wave function never collapses. Maybe all the possible outcomes described by the mathematics continue to exist. Maybe reality does not pick one path and discard the rest. Maybe it branches. In one branch, this happens. In another, that happens. And the reason you only ever see one result is that after the interaction, there are different versions of you in different branches, each aware of only the outcome in their own branch. Reality stays whole. Experience becomes local. If that sounds enormous, that is because it is. It turns every quantum event into a kind of branching structure. Not necessarily dramatic in the everyday sense. Most quantum branching would be invisible to us, buried under the smooth, large-scale world of chairs and weather forecasts and missing socks. But at the fundamental level, the idea says the universe is constantly differentiating into non-interacting branches corresponding to different outcomes. There is no magical collapse. There is only the unfolding of all possibilities allowed by the quantum state. Many worlds, as it later came to be known, is not an extra decoration added to quantum mechanics. Its supporters would say it is what you get when you take the equation seriously and refuse to insert a special collapse rule by hand. Now, at this point, a sensible person may wish to object. Even if there are branches, what could that possibly have to do with immortality? Quite a lot, unfortunately. Imagine some event with multiple possible outcomes, one of which is harmless and one of which is fatal. In ordinary thinking, there is just a probability distribution over what may happen. In many worlds thinking, there are branches in which each allowed outcome occurs. In some branches you continue, in some you do not. From the outside, considering the full multiverse, there is no miracle here. Plenty of versions of you are lost. But from the inside, from the perspective of conscious experience, the argument goes differently. You never find yourself in the branches where consciousness has ended, because there is no you there to have the experience of not continuing. Subjectively, your awareness would only ever seem to proceed along branches in which it remains possible. This is where the idea gains its eerie grip. It shifts the question from do people die to what would it be like, from the first-person point of view to encounter the end of conscious experience. And that question is much harder than it first appears. You can observe other people dying. You can reason that you will die. You can understand it perfectly well as a biological fact, but the direct first-person transition into non-experience is not something that can be experienced in the usual sense. Quantum immortality takes that gap and drives a very speculative wedge into it. If there are always multiple branches, and some tiny sliver of them allow consciousness to continue, then maybe subjective awareness is never present in the branches where it stops. Maybe from the inside it would always feel as if, improbably, things somehow continued. Before this starts sounding comforting, it is worth noticing that it is not. Not really. People hear the word immortal and imagine a prize. They imagine endless youth, endless vitality, endless summer evenings and a suspiciously flattering breeze. Quantum immortality offers none of that. It does not promise health. It does not promise happiness. It does not promise that your knees will cooperate. It does not even promise a coherent, meaningful continuity in any ordinary human sense. It simply raises the possibility that conscious experience might continue in whichever branches still permit it, even if those branches become stranger, narrower, and more improbable over time. That is not a heroic fantasy. It is more like being trapped in the logic of survival itself. There is also a reason serious people tend to treat this as a thought experiment rather than a discovery. Quantum immortality depends on several controversial assumptions layered one on top of another like a very unstable trifle. First, many worlds has to be correct, or at least something close to it. Second, identity across branches has to work in a way that makes subjective continuity meaningful. Third, consciousness has to track those surviving branches in the way advocates imagine. None of those points are straightforward. Physics does not currently hand us a neat certificate saying, "Congratulations, your awareness will now continue through the most statistically awkward route available." Quite the opposite. The whole idea sits at the border where physics, philosophy of mind, probability and personal identity begin stepping on each other's toes. Still, the reason it fascinates people is easy to understand. It combines two irresistible ingredients. One is modern quantum theory, which already feels like reality behaving with a completely straight face while saying impossible things. The other is the oldest human question of all, namely what happens to me, not what happens to matter, not what happens to the species, not what happens to civilization, me. This particular point of view, this stream of awareness reading or listening right now, it is the question hidden underneath a great deal of religion, philosophy, and late-night staring at the ceiling. Quantum immortality does not answer it in a comforting religious way, with reunion and justice and pearly administrative procedures. It answers in a coldly mechanical way. If there are enough branches, and if experience only occurs where experience continues, then perhaps your own ending is never encountered from the inside. You can see why that would keep a person awake, which is not ideal for us. But here we are. It also forces us to think carefully about what we mean by you. In ordinary life, we talk as though identity is simple. You are the child in the school photo. You are the person paying the electricity bill now. You may one day be the older version of yourself muttering about how buttons used to be better made. There is change across time, but there is enough continuity of memory, body and personality that we use one name for the whole line. Many worlds complicates that. If branching occurs, there may be multiple future versions of you, all equally continuous with the person you're right now up to the moment of branching. Which one is really you? All of them? None of them? Is identity a single thread? Or is it more like a rope that can split into strands? Once you start asking those questions, immortality becomes less like a simple promise, and more like a paperwork problem for metaphysics. Consider a smaller example before the grander one. You flip a quantum coin, if such a thing were perfectly arranged, and the future branches into one outcome where you see heads and one where you see tails. Both future observers remember being you a moment earlier. Both feel like the rightful continuation. Neither feels like a copy from the inside, yet from your present point of view, you cannot expect to become both in the ordinary first-person sense. You know that after the split there will be two future observers, each with an equally good claim to your past. Already, personal identity starts behaving less like a straight road, and more like a forked path in a dark wood, except with more equations and fewer birdsong effects. Now stretch that logic towards survival. If in one branch an event goes badly, and in another it does not, the surviving future observer will still say, quite naturally, "Well, here I am." From their point of view, continuity remains intact. The non-surviving branch has no witness left to report anything at all. That asymmetry is what gives quantum immortality its force. Experience seems biased toward continuation simply because there is no experience on the other side of discontinuation. The claim is not that the universe protects you. It is that the structure of observation may make non-observation impossible to encounter. That is a subtle distinction, and perhaps the most important one. It moves the idea away from fantasy and into something much stranger, a claim about what can and cannot appear within conscious perspective. And yet even this should make us cautious. Subjective continuity is not the same as magical invulnerability. The outside world would still contain loss, grief, endings, funerals, all of the ordinary facts that make mortality real. Other people would not experience you as immortal. Statistics would not bend themselves into a halo around your life. On the broad view, the branches in which a person dies are not erased. They exist right alongside the ones in which survival continues. Quantum immortality, if it means anything at all, applies only to the first-person thread of awareness, and even that interpretation is heavily contested. From the larger perspective, it may be better to call it quantum survivorship bias taken to a metaphysical extreme. That may sound almost comical, but it is useful. We already understand survivorship bias in everyday terms. If you only interview successful business founders, you may conclude that every risky choice was brilliant. If you only read the stories of people who pulled something off, you forget the silent pile of people for whom it went badly. Quantum immortality takes that pattern and places it inside consciousness itself. The branches in which awareness continues are the only ones from which awareness can speak. That does not prove that continuation is special. It may merely guarantee that any observer will only ever report finding themselves in observer-friendly conditions, rather like asking fish where the water seems common. So tonight's starting point is not a conclusion but a doorway. We have a theory of quantum mechanics that may or may not involve branching worlds. We have a question about why experience always seems to be happening from somewhere. We have an unsettling suggestion that from the inside you may never directly meet your own ending, only ever the next surviving version of events. Whether that suggestion is profound, confused, brilliant, or quietly nonsensical is exactly what makes it worth exploring slowly. Because before we can decide whether the idea says something real about consciousness, death, and the structure of the universe, we need to take a closer look at the place where all of this begins, down in the tiny domain where quantum mechanics stopped reality from behaving in the tidy way everyone had hoped. To see why that thought has such a grip on people, it helps to stay for a while with the most ordinary part of it, which is not quantum theory, not parallel worlds, not Hugh Everett at his desk trying to tidy up the mathematics of reality, but the simple fact that your own ending is a very peculiar thing to think about. Other people's endings are sadly familiar. History is full of them. Families are shaped by them. Every town has markers for them. We understand perfectly well in the broad human sense that lives stop. Bodies fail, systems break down, time does what it always does, and eventually someone who was present is no longer present. None of that is difficult to grasp intellectually. In fact, it is almost too easy. We build our calendars, our insurance policies, our medical systems, and our entire emotional lives around the knowledge that existence is temporary. Mortality is not some exotic theory hiding in a basement laboratory. It is the rule under which almost every creature that has ever lived has quietly operated. And yet the moment you try to turn that very solid, very public fact into a first-person experience, something strange happens. The thought becomes slippery. You can imagine being old. You can imagine being weak. You can imagine being in a hospital bed, perhaps, or in some quieter place. Hearing the room in fragments and knowing that the end is approaching, you can picture the scene. You can picture what others might say, or how the light might look, or how absurd it would be if someone chose that moment to adjust a noisy chair. The human brain is extremely good at building scenes, but then there is a point beyond which the picture stops cooperating. You can imagine the approach to the end, but not the end itself as something you will experience in the ordinary way. The movie keeps asking for a viewer. The mind keeps leaving a little witness in the room. There you are, somehow still present, imagining your own absence with all the technical success of a man trying to bite his own teeth. That is the basic tension. Death, in the third-person sense, is easy to understand. Death, in the first-person sense, is almost impossible to represent. That may not sound like much at first. It can seem like a trivial limitation of imagination, the sort of thing one notices, nods at, and then gets on with making tea. But it becomes more interesting the longer you sit with it, because consciousness is unusual in this respect. Most things can be represented from outside. A tree falls, a glass breaks, a star collapses, a machine shuts down. We can describe the event, model it, observe it, and form a decent understanding of what ending means in each case. But conscious experience is different because any account of it from the inside already presupposes its presence. To talk about what it is like for experience to stop is to ask for a report from a place where no report exists. The subject disappears from the scene, and with it disappears the very thing we would need in order to frame the event as lived. People have noticed this for a very long time. Philosophers have circled around it in different ways, sometimes calmly, sometimes with the air of someone trying not to panic while reorganizing the furniture of reality. Epicurus, for instance, put the point in a famously blunt form. When we are here, death is not here, and when death is here, we are not here. There is something almost annoyingly tidy about that. It is the philosophical equivalent of someone handing you a very neat little box and saying, "There, all your anxiety now fits inside this." For some people it works, for others it merely sharpens the problem. If the absence of experience cannot be experienced, then the fear of death begins to slide into a fear not of some event within life, but of the absolute termination of perspective itself, which unfortunately is still hard to get emotional purchase on. We can dread it. We can reason about it. We can watch it happen around us. But we never manage to stand inside it and say, "Ah, yes, so this is what non-being feels like." That impossibility produces a very odd kind of comfort. Not comfort in the sense that everything is fine, clearly. Not comfort in the sense that mortality disappears. Rather, it creates a kind of narrow subjective shelter. Whatever death is objectively, from the point of view of lived awareness, it is never encountered as an ongoing condition. No one wakes up inside non-experience and gives a review. There is no travel guide. There is no list of amenities. There is not even bad coffee and a disappointing waiting room. The thing you fear is not something you can inhabit. That does not remove the fact of death, but it does make the relation between fear and event somewhat unstable. We are frightened by something that, in the only sense that matters subjectively, never presents itself as a state of consciousness. A simple comparison helps. Think about sleep, especially dreamless sleep. People often use it as a loose analogy because every night consciousness seems to vanish for a while and then return. You lie down, thoughts become disorganized, time loses its tidy shape, and then morning arrives with suspicious speed. 8 hours may pass, and from the inside it can feel as if no time passed at all. You do not usually experience each second of unconsciousness ticking by in a neat sequence. There is just a gap, and then a resumption. That does not mean sleep is the same as death, of course. Biology is still doing quite a lot during sleep, and the continuity of the organism remains intact. But the structure of the experience is suggestive. Your subjective world contains interruptions more often than you notice. Anesthesia does something similar, sometimes even more starkly. One moment someone is adjusting the mask and reassuring you that everything will be fine, and the next moment you are awake somewhere else with a dry mouth and a new respect for ceiling tiles. The period in between is not experienced as a long corridor of nothingness. It is simply absent from the stream. That fact has a curious psychological effect. It reminds us that consciousness does not seem to possess direct access to its own absence. It only ever awakens into presence again. From the inside, awareness is always arriving in the form of a current moment. It does not sit outside time and monitor its own interruptions like a very diligent security guard. It blinks out, if that is even the right phrase, and then when it is there, it is there. This is one reason the thought of never reaching your own ending starts to feel less absurd than it first sounds. Experience has a built-in asymmetry. Whenever there is experience, there is a present. Whenever there is not, there is nothing it is like. That sounds obvious. But obvious ideas are often the ones that turn troublesome when you apply them carefully. Now, in ordinary life, we keep this in perspective because we know perfectly well that subjective limitation does not override physical reality. You may not experience your own absence, but your absence still matters enormously to the world around you. It matters to the people who know you, to the unfinished tasks on your desk, to the chair that will no longer be occupied in quite the same way. Mortality is not cancelled because the first-person viewpoint cannot stare directly at its own disappearance, and it would be a serious mistake to slide from "I cannot experience non-experience" to "therefore I must somehow continue." That leap is exactly where caution is required. The gap in imagination does not automatically imply survival. It may only reveal a limitation in what consciousness can represent about itself. A missing picture is not evidence of an invisible bridge. Still, the comfort remains, and it is not entirely irrational. Much of our fear is organised around scenes, around anticipated feelings, around being trapped inside some future condition. Pain can be feared because pain is imaginable. Loss can be feared because loss is imaginable. Isolation, humiliation, helplessness, all of those can be projected into the future with painful clarity. But sheer non-experience is more elusive. It cannot be contemplated in the same lived way because contemplation itself already defeats it. The mind may stand at the edge of the idea, but it does not step across. So there is a modest relief hidden in that fact. Whatever the end is, it is not a prolonged first-person torment of being gone. The fear belongs to life. The event, if it comes as a total end to experience, contains no one left to bear it as an experience. This is where the subject begins to tilt from the merely philosophical toward the psychologically uncanny. Because once you notice that awareness only ever knows itself as present, you start to wonder what exactly counts as the continuation of that awareness. Is it enough that there is a later conscious state connected to the earlier one by memory? Is there some deeper thread, some indivisible you that either persists or does not? In everyday life, we answer these questions lazily, and with good reason. Continuity seems obvious. You wake up and feel that you're the same person who went to bed, more or less, allowing for the usual overnight confusion and the occasional dream that insists you are late for an exam in a building that does not exist. Memory overlaps, personality overlaps, the body overlaps, and so the line of identity is treated as unbroken. No one demands a metaphysical certificate each morning before brushing their teeth, yet the closer we look, the less simple this continuity becomes. You're not physically identical to your past self in any strict sense. Your body changes, your memories shift, your beliefs alter, your cells turn over, and time works on you with calm persistence. Even psychologically, continuity is patchy. Large portions of your life are forgotten. Emotional priorities that once felt central become almost unrecognisable. The child version of you, the teenage version, the exhausted adult version trying to remember whether the oven is on, these are not identical beings in any simple way, and yet we treat them as one person because there is enough continuity of structure, enough causal linkage, enough carried forward memory and embodiment that identity feels practical. It is not perfect sameness that gives you a self. It is connectedness. That matters because the strange comfort of never reaching your own ending depends on a very particular idea of connectedness. If consciousness resumes after a gap, as in sleep or anesthesia, we count that as the same ongoing life. If a future conscious state grows out of the present one through an ordinary chain of biological continuity, we call it you. But what if reality allows multiple connected futures? What if more than one later observer can claim equal continuity with the present moment? Suddenly the question is no longer just whether awareness can imagine its own absence. It becomes a question about which future awareness counts as the one you should expect to be. An expectation is a slippery word here. Normally you expect one future because ordinary life appears not to branch in any visible way. You cross the street or you do not. You take the call or you ignore it and deal with the consequences later. Things happen once and the world moves on. That picture may be good enough at human scale, but part of what makes quantum thought so disturbing is that it suggests the underlying structure might be less singular than it appears. At the smallest levels, the world may not resolve itself into one neat narrative as quickly as common sense would prefer. The tidy world of tables and weather and long supermarket receipts may rest on something much stranger, something in which multiple possibilities are encoded together before interaction separates them into distinct outcomes. Before getting there, though, it is worth noticing how much of the emotional appeal of quantum immortality is already present without any quantum mechanics at all. It lives in the ordinary first-person grammar of consciousness. I am here now. If I am aware later, I will call that later awareness me. If there comes a point beyond which there is no awareness, I will never experience the state of there being none. So from the inside, life always seems to be encountered as an ongoing present wherever it is encountered at all. That is the seed. Quantum immortality does not create the seed. It only tries to give it a cosmological greenhouse and see what alarming thing grows. There is also a darker side to the comfort, and it deserves to be stated plainly. The fact that you cannot experience your own non-experience can easily become a trap for thought. It can tempt a person into feeling that some kind of guaranteed continuation must exist simply because subjectivity cannot picture its own disappearance. But the inability to picture something is not a law of nature. Human intuition fails all the time. We are bad at very large numbers, bad at very small scales, bad at probabilities, bad at imagining geological time, and generally overconfident about all of it. So it would be reckless to build a doctrine of survival out of a limitation in introspection. Calmly put, the strange comfort is real as a feature of consciousness, but it is not yet evidence for anything beyond consciousness. Even so, it changes the emotional atmosphere around mortality. It softens one edge while sharpening another. The softened edge is this: the end is not a condition in which you sit and suffer being absent. The sharpened edge is this: if awareness only ever knows itself as present, then every moment of being conscious carries the quiet implication that from the inside, experience is always found on the side where it still exists. That can sound trivial, but under the right interpretation it becomes explosive. It suggests a built-in observational bias. Of course you find yourself in a world where you're here to find yourself in it. Of course your experience occurs only in conditions compatible with your experience. The ordinary anthropic principle already leans in this direction on a cosmic scale. Observers observe observer-friendly conditions because otherwise there would be no observers. Quantum immortality pushes the same style of reasoning down to the level of individual survival, which is where things become uncomfortable. Imagine a branching structure of possible futures, just as a bare conceptual tool for the moment. In some futures you continue, in some you do not. If conscious observation only exists in the futures where consciousness remains, then from the inside there is an inevitable bias toward finding yourself in survivable continuations. Not because those continuations are likely overall, and not because the universe owes you anything, but because unsurvivable continuations contain no observer to register them. Already you can feel the strange comfort taking a more definite shape. It is no longer merely, I cannot imagine being dead. It becomes, perhaps the only futures I can ever encounter are ones in which I am still here to encounter them. Now that is still far too quick and much too speculative to accept at face value. But you can see why it seduces people. It transforms a familiar introspective puzzle into a claim about the structure of reality. It says the privacy of consciousness is not just a psychological oddity. It may be telling us something about which branches of the universe are ever available from the first-person point of view. Whether that is profound insight or elegant confusion is exactly what we need to sort out. And to sort it out, we have to move away from the human-scale feeling of the problem and step into the place where the underlying machinery becomes visible. Because all of this, every bit of it, depends on whether the physical world truly does contain unresolved possibilities that can develop into multiple outcomes without collapsing into one final story. If the microscopic world is classical in the old tidy sense, then the whole idea collapses before it begins. If, on the other hand, reality at its base behaves according to quantum rules that do not choose a single outcome in the way we once assumed, then the strange comfort of never reaching your own ending stops being just a philosophical quirk and starts leaning toward physics, which is usually the moment everyone in the room becomes either very interested or quietly unwell, depending on temperament. So the next step is to leave behind the familiar scale of bodies and biographies and head downward into that tiny domain where particles refuse to act like sensible miniature objects, where possibility seems to linger as something more than ignorance, and where the world first gave scientists reason to suspect that reality may be doing several things at once before we arrive to call one of them the result. It is, as it turns out, a very odd place to go looking for answers about mortality. Not among graveyards, not among old myths, not in medical textbooks or tragic poetry, but in the behaviour of the smallest things we know how to study. Electrons, photons, atoms, little pieces of the world that do not behave like neat miniature marbles, with well-behaved opinions about where they are and what they're doing. If the human-scale world feels stable, solid, and politely committed to one event after another, the microscopic world underneath it seems much less eager to settle on a single story. And that is where the trouble begins. For a long time, physics encouraged a very reassuring picture of reality. If you know where something is, how fast it is moving, what forces are acting on it, and you have the right equations, then in principle you can calculate what happens next. The universe may be complicated, but it is not undecided. A planet orbits, a thrown ball follows its path, a pendulum swings. Even when prediction becomes impractical, the underlying philosophy still feels clear. Things have definite properties whether or not anyone is looking. Your keys are either on the table or not on the table. Admittedly, there is a third possibility, which is that they are in the refrigerator for reasons no one can now explain, but even then they do have a location. Classical physics was built on that sort of confidence. The world might be difficult to measure, but it was still assumed to be definite. Objects had positions, velocities, trajectories. Uncertainty, when it appeared, belonged mostly to us. We did not know enough, or could not measure finely enough, or had lost the paperwork. Nature itself was presumed to be straightforward beneath our ignorance. If you could zoom in far enough and gather enough information, you would find the same kind of decisiveness all the way down. Then physicists started looking more carefully at atoms and radiation, and the world declined to cooperate. At the quantum level, the old picture began to fray. Light, for one thing, behaved at times like a wave, and at times like a stream of particles. Electrons did the same kind of unhelpful thing. Energy seemed to come in discrete packets. Atoms emitted light in sharply defined frequencies rather than a smooth smear. Tiny systems refused to behave according to the comfortable rules that work so beautifully for apples, planets, and inconveniently dropped cups. It was not just that the classical equations were a little inaccurate down there. It was that the very language of classical certainty stopped fitting the evidence. The new framework that emerged, quantum mechanics, was astonishingly successful and deeply strange. That combination is really the source of most of the trouble. If it had merely been strange, people might have dismissed it. If it had merely been successful, perhaps they could have slipped the weirdness under a rug and carried on. But it was both. Quantum mechanics predicted experimental results with extraordinary precision, while inviting us to think about reality in a way that seemed almost designed to irritate common sense. One of the central ideas is superposition, and this is the point where people often become understandably suspicious. In everyday language, it can sound as though physicists are saying a thing is literally doing contradictory things at once. and in a certain limited sense that is not far off, though one has to be careful. A quantum system is described by something called a wave function, which encodes the different possible states the system may be found in, and the amplitudes associated with them. Before a measurement, the system may be in a superposition of different possibilities, not settled into one ordinary classical state. It is not simply that we do not know which state it is in, as though the universe has made up its mind and hidden the answer under a cushion. The mathematics suggests something stronger. The system genuinely evolves as a combination of possibilities. If that sounds abstract, the most famous illustration is the double-slit experiment, the old favourite of science communicators and anyone who enjoys watching reality misbehave in public. Imagine firing particles, say electrons, one at a time toward a barrier with two narrow slits, and then detecting where they land on a screen behind it. If electrons were just tiny billiard balls, you would expect a fairly straightforward result. Some go through the left slit, some through the right, and the pattern on the screen reflects those two routes. Simple, sensible, very little existential damage done. But that is not what happens. When both slits are open, and no measurement determines which slit the electron passes through, the pattern that builds up on the screen is an interference pattern, the sort of pattern you get from waves interacting. It is as if each electron somehow behaves like a spread-out wave passing through both slits and interfering with itself. And yes, physicists have tried this with electrons sent one by one, because naturally once reality starts acting this way, one feels obliged to make sure it is not a practical joke. The interference pattern still emerges over time. Each detection is a single localized event, but the overall distribution reflects wave-like interference. Then comes the part that sounds almost rude. If you place a detector at the slits to determine which path the electron actually took, the interference pattern disappears. Now you get the kind of result you would expect from particles taking one route or the other. So before measurement, the system behaves as though both paths matter. With measurement, it behaves as though one definite path occurred. The act of determining which one seems to change what is observed. At this stage, almost everyone has the same reaction, whether they say it aloud or not, which is something like, "Excuse me?" That reaction is appropriate. It means you are still awake enough to be alarmed. The double-slit experiment is not mystical in the lazy and sense and fog machine sense. It is a clean, repeatable, physical result. The weirdness is not decorative. It sits inside the formalism itself. Quantum systems evolve smoothly according to the Schrodinger equation, spreading through possibilities in a precise mathematical way. But when we perform a measurement, we do not observe a blurry superposition. We observe one result. The electron lands here, not there. The atom is found in this state, not all of them at once in some conveniently poetic haze. The math gives a spread of possibilities. Experience gives a single actuality. Bridging that gap is what became known as the measurement problem. It is worth slowing down here, because this is the fault line on which the rest of our story rests. Quantum mechanics tells us how the wave function evolves. Fine. It can assign probabilities to outcomes. Also fine. But what exactly causes one specific observed result to appear? Does the wave function physically collapse when measurement occurs? If so, what counts as a measurement? A conscious observer? A detector? Any interaction with the environment? Why should there be two different kinds of evolution? One smooth and deterministic under the Schrodinger equation, and another abrupt and probabilistic at measurement. Nature is not usually so fond of switching rules halfway through the game. The traditional textbook way of speaking often uses the language of collapse. Before measurement, a system is in a superposition. After measurement, the wave function collapses to one outcome, with probabilities given by the Born rule. This works perfectly well as a recipe. It tells you what numbers to expect in experiments, and physics is full of recipes that are useful before they are fully understood. But as an account of what reality is doing, collapse leaves many people dissatisfied. It sounds less like an explanation, and more like an emergency procedure inserted to stop everyone asking further questions. and physicists, inconveniently, are very good at asking further questions. To understand why this matters for our larger subject, consider what the wave function seems to represent. In one reading, it is just a tool for calculating probabilities, a sophisticated accounting device with no obligation to correspond directly to physical reality. In another reading, it describes something real about the system, a genuine physical state evolving through time. If you take the second view seriously, then superposition cannot simply mean we do not know yet. It has to mean that reality itself, at least before measurement, has not narrowed down to the single definite picture that classical intuition demands. A famous example meant to dramatize the issue is Schrödinger's cat, though poor Schrödinger introduced it partly to show how absurd certain ideas seemed when carried into the macroscopic world. The setup is familiar enough by now. A cat is placed in a box with a radioactive atom, a detector, and a mechanism that releases poison if the atom decays. Quantum mechanics describes the atom as evolving into a superposition of decayed and not decayed states. If the whole setup is treated quantum mechanically, then before observation the entire system becomes entangled. Atom decayed, detector triggered, poison released, cat dead, atom not decayed, detector silent, poison contained, cat alive. The wave function includes both branches, yet when the box is opened we do not find a cat that is somehow hazily alive and dead in the ordinary sense. We find one definite cat, with what we may assume is a strong opinion about the experiment. Schrödinger's cat is often misunderstood as a claim about literal everyday cats hovering in magical ambiguity. It is really a way of forcing the measurement problem into the open. If quantum mechanics applies universally, why should superposition stop at small systems? At what point does the neat spread of possibilities become one observed result? Does the border lie between atom and detector, detector and cat, cat and scientist, scientist and conscious awareness? You can see why people began developing headaches. Another key idea here is entanglement, which is one of those terms that sounds almost romantic until you learn what it involves, and then becomes much less suitable for greeting cards. When two quantum systems interact, they can become entangled in such a way that their states are no longer independently describable. The combined system has a definite quantum state, but its parts do not possess separate standalone descriptions in the classical sense. Measure one, and the outcome is correlated with the outcome for the other, even when they are far apart. This does not allow for faster-than-light messaging, disappointingly, but it does show that the quantum world is knitted together in a way that resists the old picture of isolated objects carrying around their own tidy private properties. Entanglement matters enormously because measurement itself can be understood as entanglement spreading. A system interacts with a measuring apparatus. The apparatus becomes correlated with the system. Then the environment joins in. More particles, more interactions, more correlations, until the whole situation becomes effectively impossible to reverse. This is where decoherence enters the story. Decoherence explains why quantum superpositions are so difficult to observe at large scales. Interactions with the environment rapidly destroy the phase relationships needed for interference between different components of the wave function. To put it more gently, the world is nosy. Tiny systems do not remain neatly isolated for long. They become entangled with everything around them, and the delicate quantum behavior that is obvious in carefully controlled experiments gets smeared out into something that looks classical. Decoherence is a powerful idea, and it explains a great deal about why the large-scale world appears definite, even if the underlying dynamics are quantum. It helps us understand why we do not routinely observe chairs in superpositions of being in the kitchen and the hallway. Though judging by some households, keys still manage a convincing imitation. But decoherence does not by itself solve the deepest version of the measurement problem. It tells us why interference between alternatives becomes negligible. It does not fully explain why one particular outcome is the one you experience. It turns a neat superposition into effectively separate branches that no longer influence each other in practice. But then we're left with the awkward question: separate branches of what? If you're beginning to suspect that the trouble is not in the mathematics but in our insistence that experience must line up with one exclusive result, you're moving toward exactly the region where later interpretations begin to diverge. Before getting there, though, it helps to make one thing clear. Quantum mechanics is not saying that human thought magically creates reality by staring at it hard enough. That popular simplification has done a great deal of damage, usually with a tone of confidence that it has not earned. Observation in physics does not require a solemn person in a lab coat gazing meaningfully at an electron. What matters is physical interaction, the creation of correlations, the entangling of systems. Consciousness may be philosophically relevant to some interpretations, but quantum theory itself does not need the human mind as a cosmic light switch. The moon, to borrow the famous spirit of the objection, does not wait nervously for your approval before existing. Even so, the theory still leaves us in a peculiar position. At the level of equations, possibilities evolve together. At the level of experience, outcomes arrive one at a time. Between those two lies one of the great interpretive disputes in all of science. Some say collapse is real. Some say hidden variables exist beneath the apparent randomness. Some say quantum states merely reflect information. Some say we should stop asking what quantum mechanics really means and be grateful it keeps our electronics functioning. This last position has a certain exhausted charm, but it is not philosophically satisfying if you're the sort of person who wants to know what kind of universe you actually inhabit. And for our purposes, the question matters because quantum immortality only even enters the room if reality does not choose in the old singular way. If one outcome truly happens, and all others are simply unrealized possibilities, then the story remains probabilistic but single-threaded. You may survive or not survive, and that is that. No branching line of continued awareness slips through the gaps. The strange comfort stays at the level of introspection and goes no further. But if the wave function never really collapses, if the different outcomes continue as physically real components of a larger structure, then the meaning of what happens next becomes much more complicated. This is the point where the microscopic weirdness starts quietly leaning toward philosophy of identity. Because if quantum events do not resolve into one world, but into multiple effectively separate continuations, then the future may not be a single destination. It may be a set of diverging observer states, each internally consistent, each inheriting the past up to the point of branching, each experiencing one definite outcome and none of the others. The tiny world's refusal to choose would then ripple upward into our understanding of persons, histories, and endings. You would not merely be asking which outcome occurred. You would be asking which future version of an observer gets to say, naturally and sincerely, that this is what happened. That is a much bigger question than the one physicists thought they were signing up for when they started firing electrons at barriers. It also helps explain why the quantum world can seem almost tailor-made to produce both wonder and confusion. On the one hand, its predictions are precise, testable, and indispensable. On the other, its basic picture of reality does not sit comfortably with our evolved intuitions, which were trained for throwing stones, avoiding predators, and perhaps remembering where the berries were, not for understanding probability amplitudes in Hilbert space. There is no particular reason the universe at its deepest level should resemble the kind of world our monkey-inherited common sense expects. Still, we continue to be mildly offended when it does not. So here we are. In the small-scale structure of matter, reality appears to unfold as a spread of possibilities governed by exact mathematics. Measurement does not simply reveal a pre-written answer in the old classical sense. Something subtler is happening, something involving superposition, entanglement, decoherence, and the persistent mystery of why experience seems to land on one result. The tiny world refuses to choose in the tidy way we hoped, or at least it refuses to explain, in plain language, how choosing is supposed to work. and once that door is open, someone is eventually going to walk through it and ask the question that changes the whole tone of the discussion. What if nature never chooses at all? What if collapse is not a physical event, but only a feature of how observers find themselves inside one branch of a much larger quantum reality? That was the possibility a young physicist named Hugh Everett took seriously, and with it the quiet measurement problem stopped being a technical nuisance and started becoming a theory of worlds. The person who carried that question farther than almost anyone expected was not, at least at first glance, a figure designed for myth. Hugh Everett III did not arrive wrapped in mystical language or grand theatrical pronouncements about the fate of reality. He was a young physicist, mathematically gifted, stubborn in the useful way that often makes science advance, and willing to look at the formalism of quantum mechanics with a kind of impolite literalness. Where others were prepared to work with the theory as a practical tool and leave its deeper meaning politely underexplored, Everett kept pressing on the part that did not fit. If the equations describe a physical system evolving smoothly and deterministically, then why should measurement be treated as some special event that forces nature to abandon those equations and do something else entirely? Why should the universe behave one way until an observation, and then suddenly behave another way? Why insert a break in the rules precisely at the point where the philosophical discomfort becomes greatest? That was the basic irritation, and it was not his alone. By the middle of the 20th century, quantum mechanics had already proven itself beyond any sensible doubt as a predictive framework. It worked. That fact cannot be stressed enough, because almost everything strange about the theory becomes easier to tolerate in a lab once the numbers keep coming out right. Still, many physicists were not happy with the way the theory was often explained. The broad family of views associated with the Copenhagen interpretation, though never quite as singular or tidy as later summaries make it sound, encouraged a practical division between the quantum system being described and the classical apparatus, or observer doing the describing. In effect, one talked about wave functions evolving according to the Schrodinger equation until measurement occurred, at which point the wave function collapsed into one definite outcome. It was a serviceable recipe. But as an account of what really exists, it left an ugly seam in the middle of the theory. Everett looked at that seam and did something that often seems obvious only after someone else has dared to do it. He refused to treat it as acceptable. To understand why that mattered, it helps to remember the scientific atmosphere he entered. This was not a moment when the interpretive problem of quantum mechanics seemed ripe for flamboyant philosophical revolution. Physics in the 1950s was busy, confident, and increasingly oriented toward practical success. The war had changed the profession. Funding structures had changed, and attention was often directed toward problems that promised concrete results. Foundational discomfort could be tolerated if the calculations delivered. There is a long tradition in science of allowing philosophy to remain in the background until it starts interfering with the machinery. And in quantum mechanics, the machinery was running extremely well. To spend too much energy asking what the theory meant could make one appear, depending on the company, either profound or slightly unserious. Everett was at Princeton, working under John Archibald Wheeler, who was himself a physicist of immense imagination and range. Wheeler is one of those figures who seem to turn up wherever 20th century physics becomes both ambitious and a little wild. He had worked with some of the greatest names in the field, had a gift for bold conceptual thinking, and was open to problems that others might have regarded as too speculative. That mattered. A less adventurous advisor might have discouraged Everett much earlier, steering him towards safer topics and a tidier career. Wheeler, although not always able to protect Everett from the reaction his ideas would provoke, at least recognised that something unusually important was being attempted. The specific move Everett made was deceptively simple to state and deeply disruptive in its consequences. He proposed that the wave function of the entire universe should be taken seriously, not just the wave function of a tiny isolated system in a neat experiment, but of everything. Observer, apparatus, measured system, environment, all included in one universal quantum description. Once you do that, the usual language of collapse begins to look suspiciously artificial. If the whole universe evolves according to the Schrodinger equation, then there is no external observer standing outside the system to trigger a special discontinuous event. The evolution remains smooth. The wave function does not need to collapse. Instead, when observer and system interact, they become correlated. Different possible outcomes correspond to different components of the total quantum state, and each component contains a version of the observer who has recorded one definite result. It is difficult to overstate how radical that was, though radical in a very particular way. Everett was not adding extra hidden machinery. He was, in a sense, taking something away. He was removing collapse. He was saying that the mathematics may already be complete enough if we stop insisting that only one outcome becomes real in the old exclusive fashion. Measurement in this picture is not a mystical process by which possibility turns into actuality under the stern supervision of consciousness or laboratory equipment. It is just another physical interaction, one that produces entanglement and correlation between observer and observed. The unsettling part is what follows. If the wave function includes all the possible outcomes, and if it continues evolving without collapse, then those different outcomes do not disappear. They remain as distinct components of the overall state. Later language would describe these as branches, and popular culture would eventually call them parallel worlds, though both terms can be slightly misleading if taken too casually. Everett himself did not initially present the idea in the cinematic language it would later acquire. His original formulation was more restrained, more mathematical, and in some ways more austere. But the implication was there. What we think of as a single observed result may be only the local perspective of an observer who has become correlated with one outcome among many. This was not, to put it mildly, how most people preferred to think about quantum mechanics. Part of the difficulty was psychological. Collapse, however mysterious, preserves a familiar kind of singularity. One thing happens, one record exists, one future becomes actual. Many worlds, or the relative state formulation from which it developed, gives up that comfort. It tells you that the world may not choose a single continuation. It may contain all the continuations permitted by the quantum state, with observers inside each one naturally perceiving only their own result. If you ask, which one really happened? The answer becomes awkward. In the broadest sense, all of them. If you ask, which one did I see? The answer is branch local. The version of you in one branch saw one thing, the version in another branch saw another. Each feels perfectly ordinary from the inside. Each remembers the shared past up to the point of divergence. Each regards themselves as the natural continuation. That last point is where Everett's idea begins to feel less like a technical proposal and more like a restructuring of common sense. Before branching, there is one observer state. After branching, there are multiple successor observer states, each equally continuous with the earlier one in the relevant physical and psychological sense. The old hope that identity is a single line extending through time becomes hard to maintain. The future is no longer a unique destination. It is a set of correlated continuations. That, as you can imagine, did not make discussions of personal identity simpler. Everett's original dissertation, completed in 1957, was titled The Theory of the Universal Wave Function, which is a wonderful title if your aim is either to change physics forever or to guarantee that the average dinner guest becomes suddenly unavailable. The work argued that quantum mechanics could be formulated without collapse, treating observers as physical systems inside the theory rather than exceptions to it. Wheeler helped shepherd the dissertation through the process, including discussions with Niels Bohr's circle in Copenhagen, which is where things became especially difficult. Bohr, by that time, was one of the towering authorities in quantum theory, and the broader Copenhagen style of thought carried enormous weight. Whatever its internal variations, it had shaped the way generations of physicists approached the theory. Everett's proposal did not merely tweak that framework, it challenged one of its most guarded habits. the insistence that one must preserve a special role for observed outcomes and classical description. Wheeler, to his credit, took Everett's work seriously enough to bring it to Bohr's attention, but the reception was not warm. Bohr's camp was not persuaded that Everett had solved the interpretive problem. From their point of view, he seemed to be overlooking the subtlety of the observer-system distinction rather than resolving it. The irony is that Everett believed he was doing exactly the opposite. He thought he was removing an inconsistency by refusing to divide the world into quantum and classical domains in an ad hoc way. Why should the observer be exempt from quantum description? Why should measuring devices not be part of the same physical universe as everything else? If the theory is universal, then apply it universally. If it cannot be applied universally, then say so and explain why. Everett suspected that collapse was not a deep truth, but an artifact of incomplete interpretation. Not everyone appreciated that sort of honesty when it came wrapped in a thesis that appeared to populate reality with an extraordinary multiplicity of outcomes. One of the recurring criticisms, then and now, is that the interpretation buys conceptual neatness at the price of ontological extravagance. In plainer language, it avoids collapse by giving you a vast proliferation of branches. Instead of one world plus a mysterious collapse rule, you get a universal wave function with what seems like an enormous number of effectively separate worlds embedded within it. Some people find that elegant. Others think it is like fixing a squeaky door by replacing the entire house. Still, Everett's move had a certain severe logic. He was not multiplying worlds out of taste for excess. He was following the formalism where it appeared to lead if taken literally and without interruption. If the wave function is real, if it evolves linearly, and if measurement is not a magical event, then branching-like structure seems hard to avoid. The universe would then contain, in its total state, all the different correlated outcomes. The apparent uniqueness of the world you observe would be a feature of your position within that structure, not a sign that the other outcomes were erased. There is something important here that often gets lost in simplified retellings. Everett did not invent multiple worlds as a separate add-on. He proposed a way of understanding quantum mechanics in which the multiplicity comes out of the universal application of the equations. Later popularizations sometimes make it sound as though he gleefully announced from nowhere that reality consists of infinite duplicate universes endlessly splitting like soap bubbles. That is not really the texture of the original idea. The branching language became more vivid later, especially through the work of Bryce DeWitt, who did much to popularize Everett's interpretation and attach the memorable label many worlds. Everett's own presentation was drier, more formal, and in some ways more careful. That did not save him from being largely ignored for quite some time. This is one of the more melancholy parts of the story. Everett did not spend the rest of his career as the triumphant prophet of a new quantum worldview. He left academia relatively early and worked in defense-related research and consulting, including areas connected with strategy and military systems analysis. The reasons are not mysterious. Physics departments were not exactly throwing confetti in response to his interpretation, and the academic path did not open up around him in the way it might have had his work been embraced. There is a certain sadness in that. One of the boldest reconceptions of quantum theory came from someone who did not remain centrally placed within the academic conversation that later grew around it. His personal life and later years were, by most accounts, complicated and not especially serene. There is no particular need to romanticize him into a tragic genius, with the right amount of cigarette smoke and distant jazz playing somewhere in the background. Real people are untidier than that, and Everett certainly was. But the shape of the scientific story is striking enough without embellishment. A young man proposes that quantum mechanics should be interpreted without collapse, is met with skepticism, leaves the centre of academic physics, and only later sees his ideas taken up more seriously by others as the foundational debates reopen. By the 1960s and 1970s, dissatisfaction with the old orthodoxy began to re-emerge more visibly, and Everett's work acquired a second life. DeWitt in particular became a major advocate, helping present the interpretation to a wider audience in a more explicit many worlds form. Meanwhile, developments in decoherence, especially later in the century, gave the framework additional technical support by explaining how branch-like classical worlds can emerge from quantum entanglement without invoking collapse. Decoherence did not prove many worlds true, but it made Everett's style of thinking seem less absurd than it once had. It showed how different components of the wave function can become effectively autonomous from one another, no longer interfering in ways accessible at the macroscopic level. In effect, the branching worlds idea gained a more detailed account of why the branches look separate to observers inside them. That matters for our purposes because Everett did not merely split the universe in the casual science fiction sense. He split the observer. Or rather, he showed that if the universal wave function is taken seriously, then the observer's future may no longer be single. Measurement becomes self-location within a branching structure. You do not stand outside the theory and collapse reality into one answer. You become correlated with one answer, while other correlated versions of you continue elsewhere in the total state. The universe is not choosing for you. It is evolving into a set of relative observer outcome pairings. That phrase, relative state, is worth lingering over because it captures the core of Everett's move more cleanly than the later dramatic branding sometimes does. The state of a subsystem is relative to the state of another subsystem with which it is entangled. Once observer and observed interact, the observer's record is not independent of the system's outcome. There is no view from nowhere within the formalism that selects one absolute result. There are only the correlated parts of the total wave function. Each observer state finds a definite world relative to itself. You can see how, once stated that way, the connection to our larger topic starts creeping into view. If measurement produces multiple continuations of an observer, and each continuation experiences one definite outcome, then the meaning of survival changes. The future does not come as one sealed envelope. It comes as a branching set of observer histories. In most ordinary circumstances, this sounds merely odd. In extreme circumstances, it becomes unsettling. Because if some branches contain an observer who survives, and others contain an observer who does not, then the surviving branch contains someone who still says, quite naturally, that they are here. That is not yet quantum immortality, but the architecture is already in place. And perhaps that is the strangest thing about Everett's contribution. He was trying to solve a problem about the consistency of quantum mechanics. He was not primarily in the business of soothing human fear or redesigning our emotional relationship to death. Yet by refusing to let the universe collapse on command, he opened a line of thought that reaches all the way into the first-person question we began with. What happens to you if reality branches? What counts as continuation? What becomes of probability when every allowed outcome exists? And what, exactly, are you supposed to make of a theory in which the version of you asking the question may not be the only answer? The next step is where the idea stops being historical and becomes personally uncomfortable. Because once Everett has given us a universe that does not narrow itself to one observed result, we are left with a world containing multiple future versions of the observer, each equally convinced of their own ordinary reality, each inheriting the past, each moving forward along their branch as though nothing especially theatrical has happened. And once there are many future versions of you instead of just one, the obvious thing to ask is not whether the universe split, but what that means for the one person who always experiences life from the inside. Once you accept, even provisionally, the Everett-style picture of quantum mechanics, a very strange consequence appears almost immediately. The future is no longer singular in the way common sense prefers. It does not arrive as one clean result with one clean continuation of you moving into it. Instead, at least in the interpretation we are following, the future becomes a branching structure in which different outcomes continue in different branches, and different future observers exist in each of them. That is the point where people start saying things like, "So there's another me somewhere." usually with a tone that suggests they are not entirely pleased about it. That reaction is understandable. The idea sounds dramatic and also a little insulting. Most of us are attached to the thought that we are one person moving through one life in one world, not a local instance of a larger branching structure that keeps producing variants of us whenever the underlying quantum state evolves into distinguishable outcomes. We like our identity streamlined. We like our biography singular. We would like the universe, if possible, not to manufacture additional versions of us without first discussing the matter. But on the many worlds picture, something like that is exactly what happens, though not always in the cartoon version people imagine. It is tempting to talk as though every moment of indecision produces a separate universe, as if choosing tea over coffee causes reality to split with a soft administrative sigh. That way of putting it is catchy, but it is not quite right. Quantum branching is not triggered by human choices in the ordinary psychological sense. It is not your conscious will that does the branching. It is quantum interaction, entanglement, decoherence, the physical evolution of the wave function. Your choice matters only insofar as your brain and body are physical systems built on that underlying machinery. The point is not that reality watches you deliberate and then produces extra universes for dramatic effect. The point is that if the universe evolves quantum mechanically at every level, then the processes that underlie what you later call a decision may already be part of a branching physical structure. Still, from the first-person perspective, the result can be described in an almost painfully simple way. There is a present version of you reading or listening now. A moment later, after some branching interaction has occurred, there may be multiple future versions of you, each of whom remembers being this present you, each of whom feels like the natural continuation, each of whom regards themselves with complete sincerity as the real one. None of them feels like a duplicate from the inside. None of them wakes up thinking, terrible news, I appear to be the copy. That is not how subjectivity works. Each branch contains an observer with a perfectly ordinary sense of continuity. That is the first hard thing to get used to. We tend to think of copying as something that creates an original and an imitation. But branching, in this picture, does not preserve one privileged original and then stamp out a lower quality backup like a printer running low on ink. Before the branch, there is one observer state. After the branch, there are multiple successor observer states, each equally connected to the past. If you want to say one is the original, you need a reason, and it is not clear what that reason would be. The mathematics does not point to a golden thread of identity that passes into exactly one branch while ignoring the others. The branching structure treats them symmetrically. A simple thought experiment helps. Suppose you had a machine that could create an exact functional copy of you, down to memory, brain state, posture, the vague feeling that you should probably have had more water today, all of it. The machine does its work while you're asleep, and when the process is done, there are two conscious individuals in two separate rooms. Each remembers going to sleep as the person who entered the machine. Each recalls the same childhood, the same embarrassing moments, the same opinions about whether pineapple belongs on pizza. Each will insist they are you, and in the ordinary causal sense each would be right. They share the same past up to the point of duplication. The problem is not that one is fake. The problem is that our usual concept of personal identity does not know what to do when one past gives rise to two equally valid futures. That is close to the structure we are dealing with in many worlds, except the copying is not done by a suspicious machine in a badly lit lab. It is done by the quantum evolution of the universe itself. And instead of two full-sized humans standing in different rooms, immediately after a dramatic duplication event, what branches are initially the correlated components of a wave function. The future versions become effectively separate because decoherence prevents them from interfering with each other at the large scale. They do not look across and wave. There is no little window in the fabric of reality where you can peer at the version of yourself who got the other outcome and judge their haircut. The branches are dynamically isolated, which is both physically important and probably emotionally merciful. Now, this is the point where people often ask the most natural question of all. Which future version should I expect to become? And that is exactly where the old way of thinking starts to fail. If there is only one future self, the question is easy. You expect to become that person because they are the single continuation of your current life. But if there are multiple future selves, each continuous with you, then the notion of expecting to become one particular branch becomes slippery. In an objective sense, all of them exist. In a subjective sense, each future observer will find themselves in their own branch. The present you does not transform into one branch, while the others remain unreal. Rather, the present observer state is the common ancestor of several future observer states, and each one will look back and say, naturally, that they were you a moment earlier. This is where language begins to creak. We are trying to use verbs shaped by a one-world intuition to describe a branching ontology. Become sounds singular. Continue sounds singular. Wake up as sounds singular. But the theory, if taken seriously, is not singular in that way. It gives you multiple continuations, not one. The difficulty is not in the math so much as in the grammar of selfhood. You can feel the problem more sharply if you consider an ordinary quantum measurement. Imagine a detector with two possible outcomes, call them A and B. Before the measurement, you're in a state of uncertainty. After the measurement, on the many worlds account, there is a branch in which you observe A and a branch in which you observe B. Both observer states remember preparing the experiment. Both find one definite result. Neither has access to the other. From the inside, each version experiences a perfectly normal, perfectly singular observation. This is crucial. Many worlds does not tell you that you will consciously perceive multiple outcomes at once, like a person trying to watch two televisions with one pair of eyes. It tells you that there will be different future versions of you, each perceiving one outcome in the ordinary way. That feature is often overlooked, and it matters because it keeps the interpretation from becoming absurd in the wrong direction. We do not experience blurry overlap because decoherence makes the branches effectively autonomous. Macroscopic observers like us inhabit branch-specific worlds that look definite. Tables remain tables, cups remain cups, traffic remains regrettably traffic. The multiplicity exists in the total quantum description, not as a fog over your immediate experience. So when people say, many worlds sounds crazy because we do not see lots of versions of everything at once, the answer is that the interpretation does not predict that sort of experience in the first place. What it does predict is stranger in a quieter way. It says that the observer you call yourself is not followed by one future stream but by many. That means the word you stops behaving like a single destination and starts behaving like a branching relation. Right now, you refers to one present observer state. A moment later, after branching, you refers retrospectively to the shared past of multiple observers and prospectively to no unique future individual. There is no single fact of the matter about which one you will be, because all of them stand in the relevant continuity relation to you. Some philosophers have tried to make peace with this by treating personal identity as less important than psychological connectedness. On that kind of view, what matters is not a mysterious indivisible essence that either persists or does not. What matters is the continuity of memory, character, and causal structure. If multiple future people are equally connected to you, then perhaps the rational response is not to demand uniqueness, but to acknowledge that survival can come in more than one branch. This is not how everyday intuition works, but everyday intuition also once thought the sun moved around the earth, so it does not always deserve the final word. Still, it is one thing to accept branching in the abstract and quite another to apply it to yourself. The human mind is good at nodding politely through weird metaphysics until the moment it becomes personal. Then suddenly everyone wants stricter definitions and perhaps a cup of tea. If there are multiple future versions of you, do you care equally about all of them? Should you? If one branch contains a happy future and another contains disaster, what attitude should the present you take? Ordinary decision theory assumes one outcome will become actual for you. Many worlds complicates that because all outcomes occur, but not with equal measure or equal weight in the formalism. The Born rule still has to be recovered somehow to explain why probability makes sense in a branching world, and that is its own deep topic. But even before we get there, there is the immediate emotional question. If every allowed outcome produces another successor, what does prudence even mean? In normal life, the answer remains surprisingly stable. You still avoid danger, you still plan, you still behave as if probabilities matter, because branches differ in amplitude, and because the overwhelming structure of your future experiences depends on the sorts of choices and physical conditions that produce them. Many worlds is not a license to become reckless, quite the opposite as we'll see. But the identity puzzle remains in the background. The current you is like the trunk of a tree whose future is not one branch but many. Some large, some small, some healthy, some not. The trunk does not get to choose one as the exclusive continuation of treeness. And now we arrive at the phrase the user gave us, the one that sounds so direct and so misleadingly simple. Every quantum choice creates another you. There is truth in that, but it needs handling carefully. First, not every microscopic event corresponds to a psychologically distinct person in any interesting sense. Most quantum branching has nothing to do with your conscious identity as you ordinarily understand it. The universe is branching all the time in unimaginably fine-grained ways. It is not as though every electron interaction generates a dramatically new personality who immediately develops different hobbies. The vast majority of branch differences are microscopic, irrelevant to your lived self, or washed into the background of macroscopic stability. To get a meaningfully different another you, the branching has to feed into processes that affect the state of your brain, body, memory and environment in a way that produces distinguishable observer histories. Second, even when that happens, another you does not mean a separate soul with your face attached. It means a future observer physically continuous with your present state through one branch of the total quantum evolution. That may sound less exciting, but it is more accurate. The interpretation does not multiply souls. It multiplies future physical continuations, each with its own first-person perspective, and that is, frankly, strange enough. Suppose, for example, you are about to measure a spin that can be recorded as up or down. On the branching picture, there will be a future version of you who sees up, and a future version who sees down. Both are another you relative to the current present, but they are only slightly different, at least initially. Their lives diverge because one remembers seeing up and the other remembers seeing down. A tiny difference in record can later grow into larger differences in action, memory, and biography. At the moment of branching, though, they are almost the same person from any everyday standpoint. This matters because it shows that multiplicity does not arrive with dramatic thunder. It begins with ordinary observer records becoming correlated with different outcomes. The drama comes later, when we realize what this means for identity. There is a temptation here to ask whether there is a true self standing behind all the branches, something deeper that unites them. Some people find that idea emotionally attractive, but the many worlds framework itself does not require it. The present observer state is the common ancestor. The future contains multiple descendants. Asking which descendant is the real one may be like asking which fork of a road is the authentic road. It made sense before the split, but after the split the question has changed form. There are just different continuations, and if that is right, then personal identity starts to look less like a single line, and more like a pattern of overlap through time. You're not a bead sliding along a wire. You're a process, a structured flow of information and experience carried by a physical system. Processes can branch. Information-bearing structures can have multiple successors. It feels uncomfortable mainly because our emotional habits were not built for it. We're used to one name mapping onto one person across one life. Many worlds politely, or not so politely, informs us that this may be a large-scale simplification rather than a deep truth. The unsettling consequence is not only that there may be many future versions of you, but that each of them will feel ordinary. This is easy to miss because we tend to imagine weird theories producing weird experiences. In fact, the strength of the idea is that it preserves ordinary experience inside an extraordinary ontology. Each version of you gets a single coherent world, a single memory chain, a single local narrative. The weirdness exists at the level of total description, not at the level of what it feels like to be one of the observers. That is why the interpretation can be both radical and experientially quiet. No fireworks are required. The multiplication happens behind the scenes, in the architecture of reality rather than in the texture of moment-to-moment consciousness, which of course is exactly what makes the next step so disturbing. If every quantum branching event can, in principle, produce multiple future versions of you, and if each surviving observer feels like the straightforward continuation of the present self, then the issue of survival stops being a simple yes or no question. It becomes branch relative. In some futures you continue, in some futures you do not. In some futures you continue in conditions you would prefer not to imagine too carefully. The word you no longer points to one fate, it points to a family of outcomes sharing a past. And that is where a thought experiment enters the story that forces this abstract branching picture into a much sharper shape. Because once people realized what many worlds might imply for observer continuity, it was only a matter of time before someone asked the question no sensible dinner party should ever encourage. What happens if the branching is arranged so that from the inside, only the surviving observer remains to notice anything at all? That, sooner or later, is the point where the conversation stops being a strange theory of measurement and turns into a disturbing idea about experience. Once you have a branching universe and multiple future versions of an observer, someone is bound to ask what happens if the branching is arranged around survival itself. Not survival in the everyday statistical sense, where some people live and some do not, but survival from the inside, from the point of view of the observer, who can only ever report whatever they are still here to report. This is the thought experiment that gave quantum immortality its unnerving shape, and it did so by taking the many worlds picture far more personally than most physicists would ever care to do. The basic structure is simple enough to describe in the abstract, and it is much better left abstract. Imagine a hypothetical situation in which a person's continued conscious experience is tied directly to the outcome of a genuinely quantum event, one with multiple possible results. In one branch, the outcome allows the observer to go on. In another branch, it does not. If many worlds is correct, both branches exist. There is no collapse that selects only one result and erases the rest. The wave function continues into multiple correlated futures. From the outside, looking at the whole branching structure, there is nothing miraculous here. One branch contains a living observer, another does not. That is all. But from the inside, things begin to look very different, because the branch without a continuing observer has no one left in it to register that it was the end. And that is the whole unnerving trick. If conscious experience only exists where consciousness continues, then in a branching situation built around survival, the observer would only ever find themselves in the branches where they are still able to find themselves anywhere at all. Subjectively, it might seem as though survival keeps happening. Not because the universe favours them, not because the unlikely suddenly becomes likely in the ordinary third-person sense, but because awareness has no presence in the branches where it stops. The only reports that can ever be made come from the branches in which a report is still possible. This thought experiment is often given the deliberately alarming name quantum suicide, which sounds like the sort of phrase invented specifically to make professors regret allowing questions at the end of lectures. The name is memorable, but it can also be misleading. It suggests something practical, demonstrative, almost testable, and that is precisely the wrong attitude to take toward it. It is not a responsible experiment, it is not a serious method of discovery, it is not evidence, it is a philosophical device for exposing the strange implications of observer continuity in a branching universe, the point is not to perform anything. The point is to see what follows if one accepts the interpretation and then applies it to first-person experience without flinching. The reason it had such an effect is that it seems, at first glance, to do something very unusual. It appears to separate the external probabilities of events from the internal experience of the observer. Externally, across the full branching structure, there are plenty of branches in which the observer does not continue. Internally, there are only branches in which conscious awareness remains available to itself. So if you ask the question from the first-person viewpoint, what do I experience next? The answer begins to look uncomfortably one-sided. You experience whichever branches still contain an experiencer. That does not mean the dangerous branch failed to occur. It means there is no one there to say so. A calmer way to put it is that the thought experiment exploits a selection effect. Any observer can only find themselves in observer-compatible conditions. We already accept versions of this idea in more ordinary settings. You're not surprised to find yourself on a planet with liquid water, breathable air, and stable chemistry, because beings like you could not arise under just any conditions. The fact that you observe a world suitable for your existence is not in itself evidence that the world was designed for you. It may simply be a condition of your being there to observe it. Quantum immortality takes that same general structure and narrows it to the path of one individual consciousness through branching outcomes. The observer does not find themselves in branches where observation has ceased for them. That sounds almost trivial once stated, but when connected to repeated survival branches, it starts to resemble a kind of subjective guarantee. That resemblance is what made the idea famous, and also what makes it dangerous to interpret carelessly. The thought experiment does not show that a person is objectively immortal. It does not show that physical death is avoided in the universe at large. From the perspective of everyone else, ordinary mortality remains perfectly intact. Most branches may contain exactly the kinds of endings biology and statistics would lead you to expect. Families grieve, records stop, lives end. Nothing in many worlds cancels that. The claim, such as it is, exists only at the level of first-person expectation, and even there it depends on controversial assumptions about identity, consciousness, and what it means to continue as the same observer across branches. Still, you can see why people could not leave it alone. It appears to convert a technical interpretation of quantum measurement into a deeply personal statement. If all outcomes occur, and if only surviving branches contain a conscious version of you, then from the inside it may seem impossible ever to encounter your own ending. Every time reality branches around survival, awareness would only continue in the survivable branches, however improbable those become from an outside perspective. Hence the provocative phrase, "You are immortal, but not in the way you think." Not because nothing can harm you, not because the universe wraps you in plot armor, but because first-person experience may have access only to the paths where it remains first-person experience at all. The philosopher's temptation, at that stage, is to nod slowly and call this a remarkable insight. The physicist's temptation is to stare into the middle distance and mutter that everyone has become much too enthusiastic. Both reactions are understandable. The idea is gripping because it seems logical once the premises are granted. It is suspect because the premises are doing a truly enormous amount of work. One has to assume that many worlds is the correct interpretation, that observer branches are the right way to think about measurement, that consciousness tracks those branches in the relevant way, and that subjective continuity should be reasoned about exactly as the argument suggests. None of that is trivial. This is not one clear theorem leading to one clear conclusion. It is a stack of difficult questions trying to hold hands while standing on ice. There is also a subtle issue hidden in the word survive. In ordinary speech, survival means something rough but understandable. You remain alive. You continue as the same person. Your body and mind carry on in a condition recognizably connected to the earlier you. In the quantum immortality discussion, That word can begin to stretch in uncomfortable ways. Suppose there are many branches. Some contain your continued existence in a normal sense. Some do not. Some contain outcomes in which consciousness continues, but under highly degraded circumstances. If the argument only cares that some thread of awareness persists somewhere, then the theory does not owe you a good future. It does not owe you health, clarity, dignity, or comfort. It owes you nothing. It merely says that if any branch contains continued awareness, then that is where awareness would still be available. This is not the same as the cheerful fantasy of living forever. It is closer to being trapped in the bare logic of observational persistence. That is one reason thoughtful people often find the idea less comforting the longer they examine it. At first, it seems to offer escape from finality. Then you realize it does not offer escape so much as a distorted version of continuation, one indifferent to the qualities that make life recognizably worth wanting. The seductive phrase is immortality. The fine print is survivorship in some branch, under some conditions, for as long as branch relative awareness can still be said to continue. There is a coldness to that. The universe in this picture is not benevolent. It is merely permissive. The thought experiment also introduces a problem about evidence. If a person emerges from a branching situation and finds themselves alive, what exactly have they learned? From the inside, it may feel as though survival is strangely guaranteed. But that feeling does not discriminate cleanly between interpretations of quantum mechanics, because surviving observers exist in ordinary probabilistic frameworks as well. The mere fact that you are alive after a risky event does not establish that you occupy a many-worlds branch, rather than a single-world universe in which you happen to get the favourable outcome. The branches where you would not be there to reflect are by definition silent from your point of view. That means the thought experiment lacks the public repeatable structure that science normally requires. It is not that it fails to be interesting, it is that it fails to be a usable test. This is where some of the initial drama begins to cool into something more sober. A thought experiment can reveal conceptual pressure without delivering empirical confirmation. Schrodinger's cat does this. So does the twin paradox in relativity. So does the ship of Theseus for identity. They help us see where our concepts strain. Quantum immortality belongs in that family, except with the added complication that people can mistake it for a practical discovery about their own invulnerability, which it absolutely is not. The only thing the thought experiment demonstrates clearly is that first-person reasoning behaves oddly in a branching ontology. That is significant, but it is not the same as proving that no observer ever truly reaches an end. There is another difficulty, and it goes straight to the heart of personal identity. Suppose a branching event creates one branch in which you continue, and another in which you do not. The surviving future observer will certainly feel like your continuation. Fine. But that was already true in ordinary many-worlds branching. After any measurement with multiple outcomes, every successor observer feels like the natural continuation of the pre-branch self. Quantum immortality adds mortality to one side of the split, but it does not magically make the surviving observer more uniquely you than other branch successors are in ordinary cases. So what exactly is being claimed? That there is always at least one continuation? That seems plausible within the thought experiment. But is that the same as saying that you, in the singular, are immortal? Only if one already accepts a very particular view of identity, one in which any surviving successor counts as sufficient for first-person continuity. Some people accept that view readily, others do not. They point out that branching does not preserve a unique subject, it produces multiple successors. If identity is not one to many, then perhaps none of the branches is strictly identical to the earlier self, or perhaps identity is simply the wrong concept, and what matters is degree of continuity. That line of thought does not destroy the argument, but it changes its emotional colour. Instead of, I will always survive somewhere, the claim becomes something more like, There will always be some future observer strongly connected to me in the branches where continued awareness remains. That is still strange, still interesting, but much less triumphant. And then there is the matter of probability, which many worlds always has to face sooner or later. If all outcomes occur, why should branch weights matter? Why should one rationally fear branches with unfavourable outcomes if favourable branches also exist? This is not a side issue. It is central. Standard quantum mechanics uses the Born rule to assign probabilities to outcomes, and any interpretation that keeps the formalism intact has to explain why those probabilities continue to guide rational expectation. Many worlds advocates have various responses involving decision theory, self-locating uncertainty, or measures over branches, but none of them makes the emotional leap to immortality as straightforward as the popular version suggests. You do not get to ignore unfavourable branches merely because favourable ones also exist. The full branching structure still contains them. The theory does not let you treat low-measure survival branches as if they were all that matters, unless you are quietly smuggling in the very subjective bias the thought experiment is trying to analyse. The distinction between external measure and internal experience is crucial here. Externally, if the overwhelming majority of branches contain your death, then from the perspective of the full wave function, that remains the dominant fact. Internally, there may still be a surviving observer in some small measure branch. Those are not contradictory statements, but they do live at different descriptive levels, and confusion enters when people slide from one to the other without noticing. The outside view says, overwhelmingly, the person is gone. The inside thought says, wherever there is still a conscious successor, that is where subjectivity is still located. Both can be true within the framework, but they answer different questions. One is about the structure of reality. The other is about the availability of experience. This is also why the idea can become morally and emotionally distorted if handled without care. To everyone around the observer, ordinary risk remains ordinary risk. The fact that some hypothetical, subjectively surviving branch may exist does not erase the reality of harm in the branches where survival does not occur. Quantum immortality is not a reason for recklessness, and it is certainly not a reason to test anything. In human terms, the consequences remain exactly as serious as ever, because the public world in which other people live and suffer is not rescued by the existence of some remote branch in which a surviving observer continues. The argument, if it works at all, is private to subjectivity. That is precisely what makes it philosophically fascinating and practically useless. In fact, one of the strongest objections to the whole idea is that it may rely too much on a misleading picture of consciousness as something that simply hops to any branch where it survives. Many Worlds itself does not say consciousness moves between branches like a traveller picking trains. That language is far too classical and far too unified. What the theory gives you are multiple future observer states. There is no extra homunculus deciding where the real awareness goes. Each branch contains its own local continuation. The feeling that I must wake up in the surviving branch may therefore be importing a singleness of self that branching has already undermined. Once there are multiple successors, the old question, which one will I be, may simply be the wrong question. Yet even with all those objections, the thought experiment refuses to disappear because it points to something undeniably real about consciousness. Awareness never reports its own non-existence. It only ever appears where it is present. When that familiar asymmetry is placed inside a branching interpretation of quantum mechanics, the result is inevitably eerie. The observer seems chained to whichever branches still permit observation. Whether that should be called immortality is another matter. Perhaps it would be better called branch-relative experiential persistence, though admittedly that is less likely to become a best-selling phrase. The most revealing way to understand the thought experiment, then, is not as a proof of eternal life, but as a pressure test for our intuitions. It forces us to notice how much of our ordinary concept of death depends on third-person description, and how awkward first-person description becomes at the point where experience ends. It forces us to see that in a branching universe, Observer-centered reasoning may behave differently from world-centered reasoning, and it forces us to confront the possibility that the continuity we call self may not be a single line at all, but a pattern of successor states whose significance changes depending on whether we look from outside or from within. Once you see that, the haunting part of the idea becomes clearer. It is not just that there might always be a branch where you survive. It is that consciousness, by its nature, only ever seems to open its eyes from the inside of a branch where eyes can still open. That may be the whole illusion, or it may be the beginning of a very strange truth. Either way, it leads naturally to the next question, which is less about dramatic thought experiments and more about the quiet fact of everyday awareness. Why, in all the countless ways reality might be arranged, do you always seem to wake up as yourself from the inside of one continuing stream rather than anywhere else at all? That question sounds simple until you let it sit still for a moment. Why do you always seem to wake up as yourself? Not in the ordinary social sense, where the answer is obvious enough, because you went to sleep in your own bed, with your own memories, your own body, your own unpaid tasks waiting patiently in the next day. That version is easy. The stranger version is this. Why is conscious experience always located here, in this stream, with this history, from this interior point of view? Why are you not someone else? Why are you not nowhere? Why does awareness return each time it returns, in the form of this particular ongoing perspective rather than another one? Most of the time, we do not notice how strange that is, because it is buried under habit. You wake up in the morning, and there you are again. The room is familiar or unfamiliar, the thoughts are coherent or not yet coherent, the body feels rested or deeply offended, but the central fact remains the same. Experience resumes as your experience. There is no lottery sensation. There is no moment of opening your eyes and discovering that this morning you are a violinist in Lisbon, or a botanist in Osaka, or a mildly confused otter. Consciousness appears with a built-in sense of ownership. It comes pre-addressed. This is me, here, now. That sense is so basic that it hardly feels like a claim at all. It feels like the background condition for every other claim. But in a branching universe, or even in a universe full of many conscious beings, that basic fact becomes oddly difficult to explain in a clean, intuitive way. If reality contains multiple observers, why is your awareness associated with this one rather than any other? If reality contains multiple future versions of you, why does every later moment seem to continue from the inside as one local stream rather than giving you access to some broader view of all the branches at once? And if subjective continuity is what matters, what exactly is the principle by which awareness keeps appearing in one successor rather than another, or in all of them, or in none? One answer, of course, is that the question is confused from the beginning. Maybe there is no further explanation needed. Maybe asking, why am I this observer, is like asking, why is this point in space this point? There is no hidden selection process behind it. The fact simply is what it is. You are this conscious process because this is the conscious process occurring here. Experience is always indexed to the particular physical system generating it, and that is the end of the matter. On this view, there is no extra metaphysical pearl of self floating above the branches waiting to be assigned somewhere. There is just the local fact that a given brain state produces a given perspective, and when you ask why you are that perspective, you're smuggling in the mistaken idea that you could have been some disembodied spectator attached elsewhere. That may be right. In fact, it is probably the safest answer. But it does not dissolve the feeling of strangeness. The first-person character of experience remains unusual. Physics gives us descriptions from the outside. It tells us about particles, fields, states, dynamics, correlations. It can tell us, at least in principle, what structures exist and how they evolve. But the lived fact that any of those structures should be accompanied by an interior point of view is already one of the deepest mysteries we know, and once there are many such points of view, the additional mystery of self-location appears naturally. Out of all the conscious systems that may exist, here is this one being experienced from within. Why this one? Why now? Why this history? People sometimes encounter that question in a more innocent form as children. Why am I me and not somebody else? It is the sort of question adults are often tempted to dismiss because it sounds too simple, almost grammatical. But it is not simple. It only sounds simple because it is pressed so close to the structure of awareness that it has nowhere obvious to stand. We do not usually ask why a mountain is that mountain, or why a pebble is that pebble, because objects are not given to themselves from the inside. Conscious beings are. The question of being this one rather than another arises because consciousness is always from somewhere, and that somewhere is not presented to itself as a neutral coordinate. It is presented as me. In ordinary life, memory helps smooth this into something manageable. You wake up as yourself because the conscious state now is causally connected to the conscious state before sleep. Your brain maintained enough continuity, enough physical persistence, enough stored structure that the morning experience inherits the earlier one. No great metaphysical crisis required. The bridge is built out of ordinary biology. That is, in practical terms, a very good answer. But once you start thinking about branching futures, copied minds, or any scenario in which multiple later observers share continuity with one earlier observer, memory does not settle the question as neatly as it first appears. Suppose, once again, that there are two future versions of you after some branching event. Both inherit your past memories up to the point of divergence. Both feel like the rightful continuation. Each wakes up as themselves, and each self is strongly connected to the earlier you. From the outside, the situation is symmetrical. From the inside, each observer simply finds themselves where they are. There is no extra sensation of having been chosen. Each one wakes into one definite local perspective and calls it me. This is what matters. The apparent mystery of why you always wake up as yourself may not point to a deep selection process at all. It may simply reflect the fact that any conscious observer, in any branch, necessarily wakes as that observer, and not as someone else. That sounds trivial when stated plainly, but it may be the key to the entire eerie feeling around quantum immortality. Of course you always wake up as yourself. There is no other way for waking to feel. Awareness is not a generalized substance evenly smeared over reality and then concentrated by luck. It is always tied to a particular physical implementation, a particular observer state. So if multiple future observer states exist, each will carry its own first-person perspective in the ordinary local way. No one will wake up and feel all the branches. No one will wake up and think, fascinating, I appear to have been allocated to branch 7. They will simply wake up as themselves, with their own memories, in their own conditions. Once you see that, a lot of the drama shifts. The question is no longer why consciousness chooses a surviving branch. The question is whether, in a universe with many branches, any conscious successor in a surviving branch is enough to ground the feeling of subjective continuation that the earlier observer might care about. That is a more careful and more difficult issue. It is not about some ghostly self leaping between branches. It is about which future observer states stand in the right relation to the present one for us to call them continuations of the same life from the inside. There is a related idea here known as self-locating uncertainty, and although the phrase sounds as though it belongs in an especially tiresome seminar, the underlying point is useful. Sometimes your uncertainty is not about what the world is like in general, but about where you are within it. Imagine, for example, that a perfect copy of you is created while you are asleep and placed in an identical room. When you wake, before opening the door or learning any distinguishing fact, you may know the complete external story. You know there are two physically identical observers with the same memories up to the point of sleep. What you do not know is which one you are. That uncertainty is not about the overall state of the world. It is about self-location within that state. Many worlds introduces something similar after branching. The total state may contain multiple observer versions. each correlated with different outcomes. Before you register which outcome you have seen, there is a sense in which you can be uncertain about which branch local observer you are about to be, even if all branches exist. This is one way people try to preserve meaningful probability talk in a branching universe. The uncertainty is not over whether an outcome will occur somewhere. It is over which future observer perspective will be the one from which a given local experience is had. That gets us closer to the waking question. Why do you always seem to wake up as yourself? Because self-location is always local. Experience does not arrive from nowhere and then inspect the available conscious beings like a customer reading a menu. It arrives already situated. You do not first exist and then become you. The being you call you is the local pattern in which this experience is instantiated. If there are many such patterns, there are many such local first-person stances. Each one is self-locating by construction. Still, that is not emotionally satisfying to everyone because the mind keeps trying to ask for a deeper reason. It wants to know why this local stance is the one that is being felt from here. In a sense, though, that question may be equivalent to asking why this sentence is being read from the position of the reader rather than from the position of the lamp on the table. The lamp is not the kind of thing that has a first-person point of view, and the observer reading is. Once the physical basis for experience is there, the why here question may simply be a demand for a view from outside all views, which is exactly what consciousness never gives us. The deeper puzzle in our context comes when we connect this to continuation through interruptions. Sleep is not troubling because only one later waking self appears to connect naturally to the earlier sleeper. Anesthesia is not troubling for the same reason, but branching is different. If multiple later observer states each stand in that same continuity relation, then the uniqueness of waking dissolves. Not the local feeling of waking that remains perfectly intact, but the idea that there is only one future you for awareness to become. There may be many, each wakes as itself, each feels ordinary. From the present point of view that can make the future seem less like a single hallway and more like a set of doors, each opening into a different continuation, each occupied by someone who sincerely says, "Yes, I'm the one who came through." This is why quantum immortality can feel persuasive at first. If awareness is always local and only ever appears where it exists, then of course any later experience will be found in branches where later experience occurs. The branches where it does not occur are not experienced as blank spaces. They are not experienced at all. So there is a built-in asymmetry between continued awareness and terminated awareness. One can be encountered from the inside, the other cannot. The temptation is then to infer something stronger, namely that you will always wake up in whichever branch still supports you. But that inference may be too quick. It may confuse the trivial truth that experiences occur only where experiences exist with the much stronger claim that your subjective future is guaranteed to track any surviving branch, no matter how improbable. To see the gap, consider again the problem of multiple successors. If two future versions of you exist after an ordinary measurement, do you wake up as both? In one sense, yes. Both are equally valid continuations. In another sense, no. Each future observer has one local perspective and does not feel the other. The present self does not possess a single later viewpoint spanning both. So when someone says, in the context of dangerous branching, "I will wake up in the surviving branch," what exactly do they mean? If they mean that there will be at least one future observer connected to them in a branch where survival occurs, that may be true within the thought experiment. If they mean that a unique metaphysical self is guaranteed to find itself there and only there, that is much less clear. This is one reason the waking metaphor is both helpful and misleading. It is helpful because waking captures the gap-filled nature of consciousness. You lose access to a stretch of time and then find yourself present again. It is misleading because ordinary waking does not involve rival successors. You wake up as yourself because there is one later observer state causally continuous with the sleeping one in the normal human case. Branching changes that by producing several later observer states, the first-person feeling remains singular within each branch, but the underlying continuity relation is no longer one-to-one. Now, none of this means that the sense of self is unreal or worthless. It only means it may be less singular than we habitually imagine. A self can be understood as a dynamically maintained pattern of memory, cognition, embodiment, and perspective. Patterns can persist, transform, degrade, and perhaps branch. That may be enough. In fact, it may be all we ever had. The comforting fantasy of a simple, indivisible essence may be no more than a very efficient everyday shortcut. And yet everyday life continues to feel singular. You still remember yesterday as yours. You still expect tomorrow to belong in some meaningful way to the same life. This expectation is not foolish. It is grounded in the overwhelmingly stable structure of human experience. Branching, if it is real, is hidden beneath that stability. The reason you seem always to wake up as yourself is that the processes generating your consciousness are not normally producing macroscopic identity crises visible from the inside. Even in a branching ontology, each branch contains a normal-seeming local observer. That observer does not encounter multiplicity as multiplicity. They encounter one world, one body, one ongoing thread of memory. So perhaps the right answer is both humbler and stranger than expected. You always seem to wake up as yourself because any conscious waking is necessarily from the inside of one particular observer state, and because continuity of memory and physical structure makes that observer state count as you in the ordinary practical sense. There is no extra mystery of selection beyond that, unless one insists on treating the self as something over and above the process. The unsettling part comes only when there are many equally legitimate future processes connected to the present one. Then the singular language of expectation begins to wobble. That wobble is precisely what the next part of the story has to face. Because once we accept that the future may contain many successor versions of an observer, and once we see that each of them naturally wakes up as itself with no awareness of the others, we run into a morally and philosophically difficult question. If one branch continues and another does not, what exactly happens to the copies you never get to meet? The ones just as connected to your past as you are, but living out different outcomes beyond the split. There is a reason this idea earned such a grim name, not because it is a good idea, and certainly not because it reveals a hidden path to certainty, but because once the many worlds picture is joined to first-person experience, the logic can take on a shape that feels cold, private, and disturbingly persuasive if it is not examined carefully. The phrase quantum suicide is less a scientific term than a warning label attached to a philosophical trap. It points to the moment where a question about branching observer states becomes entangled with the most intimate and dangerous human subject possible, and where the neatness of the logic can briefly make it look stronger than it really is. The dark part is not only the topic itself, it is also the way the argument seems to sidestep ordinary evidence. In most matters, when something is unlikely, repeated trials settle the question quickly enough. If you flip a fair coin many times, you do not need a mystical insight to see the pattern. If an event is risky, the public world records its outcomes. There are witnesses, statistics, bodies, histories, consequences. But the quantum immortality argument shifts the centre of gravity away from public evidence and into private observation. It says, in effect, that from the inside you would only ever find yourself in the branches where you remain able to find yourself anywhere at all. The branches where you do not continue are, by the nature of the case, silent. That silence is what gives the thought its strange force. At first glance, the reasoning can seem almost airtight. If all quantum outcomes occur, and if some branches contain your continued awareness while others do not, then there will always be at least some branches in which there is still an observer to ask what happened next. From the outside, the total reality contains both continuations and endings. From the inside, awareness is present only in the continuations. So if one insists on asking only the first-person question, the whole branching structure looks heavily biased towards survival. Not because survival is objectively dominant, and not because the world has changed its probabilities, but because non-survival contains no later subject to register itself as a result. That is the logic in its bare form, and the reason it feels dark is that it seems to offer a kind of subjective escape hatch from mortality, while leaving mortality fully intact everywhere else. Other people would still see exactly what ordinary risk predicts. The world would still contain loss, records stopping, lives ending, grief moving through families and rooms and years. Nothing about the public reality becomes softer. The only apparent exception is the interior path of the observer, who, if the argument works, never seems to encounter the terminal branch from the inside. It is as if the theory whispers that death remains perfectly real for everyone else, while somehow remaining perpetually out of reach of direct experience for the one having it. That is not comforting so much as isolating. It makes survival feel less like a blessing than like an observational quirk with dreadful implications. One reason sensible people recoil from the argument is that it trades on an ambiguity about what it means to say, "I continue." In ordinary life, the statement is simple. You continue because your body remains alive, your mind remains integrated, your memories persist enough for the same life to be carried forward, and the people around you recognize the continuity. The person at breakfast is the same person who went to bed, allowing for the usual mysteries of dreams and misplaced socks. But in a branching ontology, continuation is no longer singular. There may be multiple future observer states equally descended from the present one, each with a valid claim to the past. If one survives and another does not, the surviving observer still says, "I'm here." Yet that does not magically erase the branch where the line ended. So the question becomes whether the existence of any surviving successor is enough to ground the first-person statement that you never reach your ending. The argument answers yes, or at least it leans that way. Its critics are less convinced. They point out that branching already undermines the old notion of a unique self flowing like a single ribbon through time. After a split, there are just multiple successors. Each feels ordinary locally. Each says I. None owns the whole future. So when someone says, "I would always wake up in the branch where I survive," the sentence may be smuggling in a false singularity. It may be imagining a single metaphysical subject that gets routed, like mail, toward whichever branch still permits awareness. But Many Worlds does not really give you a single subject moving between branches. It gives you multiple branch local continuations. There is no tiny witness standing above them all and choosing where to go. That matters enormously, because much of the emotional power of quantum suicide depends on exactly that imagined witness. It depends on the sense that there is a single inner self that must find itself in the surviving branch, because there is nowhere else for it to be. Once that picture is removed, the argument becomes less magical and more austere. There are branches. Some contain later observers connected to you. Some do not. The surviving ones contain someone who feels like your continuation. The ended ones contain no one. Whether that amounts to you are guaranteed survival from the inside becomes much less obvious. It may instead amount to the weaker claim that among the many future observer histories related to you, some remain conscious where others do not. Even that weaker claim, however, still has a disturbing flavour. It suggests that conscious experience is structurally biased toward finding itself wherever it still exists. And that is true in a trivial sense no matter what else one thinks. No observer ever reports observing their own non-existence as an ongoing state. There is no testimony from the other side of a terminated perspective. That asymmetry is real. The dark turn comes when the asymmetry is misread as evidence for invulnerability. Once someone begins to think, "From my point of view, I could only ever end up in branches where I continue," the argument starts imitating certainty, while quietly discarding everything that makes ordinary reasoning reliable. This is where it helps to distinguish very carefully between world-centered facts and observer-centered facts. A world-centered fact concerns the total branching structure. Which branches exist? What is their measure? How many observer states do they contain? What does the outside description say? An observer-centered fact concerns a local stream of experience. What does it feel like from the inside of one branch? What outcomes are available to direct awareness? The quantum immortality argument is persuasive only when one keeps switching between these two frames, just fast enough not to notice the switch. From the world-centered view, death remains abundant and ordinary. From the observer-centered view, only continuing branches contain later experience. Those two statements are compatible, but they are not interchangeable. Trouble begins when the existence of a local later experience is allowed to overwrite the larger fact that most of the branching structure may contain precisely the opposite outcome. Put differently, the argument is strong as a statement about selection and weak as a statement about safety. It is one thing to say that an observer can only observe branches in which an observer exists. That is almost tautological. It is another thing entirely to infer that one should therefore expect personal continuation in the robust, emotionally loaded sense people usually mean. The first claim is a feature of perspective. The second smuggles in a promise that the physics itself does not make. There is also the problem of gradual deterioration, which is often ignored in popular versions because it ruins the fantasy. If the thought experiment is taken seriously at all, it does not license the picture of an observer effortlessly gliding through an endless series of clean escapes. Reality is not obliged to provide dramatic, cinematic survivals. It need only contain some branches where conscious awareness continues in some form. That continuation could in principle become increasingly narrow, increasingly damaged, increasingly unlike the healthy, stable persistence people imagine when they hear the word immortal. A theory that merely privileges any remaining thread of awareness does not owe you a good branch. It does not even owe you a coherent one, beyond whatever minimal conditions are required for experience to persist. So the dark logic, if followed ruthlessly, offers not triumphant everlasting life, but the possibility of being dragged along by the thinnest available line of continued consciousness. That is not a hopeful picture. It is a bleak one. This is one reason the phrase quantum immortality is so misleading. It sounds grand, almost mythic. It suggests permanence, resilience, transcendence. In fact, the thought experiment, if granted its premises, describes something much colder: branch-relative experiential persistence. It says nothing about flourishing, nothing about health, nothing about dignity, nothing about whether the continued observer state remains recognisably the same person in the rich human sense we care about. The argument is satisfied by survival in the narrowest observational sense. Human beings, unfortunately or perhaps fortunately, mean much more than that when they talk about a life continuing. Another difficulty comes from probability. Many worlds is often introduced in a way that makes people say, if every outcome happens, then probability no longer matters. But that is not right. Probability, or rather something like it, still matters because branch weights matter. The born rule does not simply disappear because one prefers a branching ontology. The overwhelming share of the wave function may correspond to outcomes in which a particular observer does not continue. If a tiny sliver contains continued awareness, that sliver still exists. Fine. But it does not become representative of the whole structure simply because it remains locally experienceable. The temptation to treat what I can still observe as the only reality that counts is psychologically understandable and philosophically dangerous. It narrows the universe to the perspective that happens to remain, then forgets that it has done so. This narrowing can produce a kind of private certainty that is almost impossible to test in the scientific sense. Suppose an observer emerges from some imagined branching situation and finds themselves conscious. What have they learned? Only that they are in a branch compatible with consciousness. That was guaranteed by the fact of observation itself. They have not thereby shown that many worlds is true. They have not shown that subjective immortality follows. They have not shown that the branches without a continuing observer somehow failed to exist. The evidence is radically underdetermined because the observer can never sample the outcomes in which they are absent. Public science depends on shareable records and cross-observer agreement. Quantum suicide as a thought experiment points precisely toward a region where those conditions break down. It is therefore a poor route to knowledge, even if it is a very effective route to metaphysical unease. One could even say that the idea is a sort of weaponized survivorship bias. Ordinarily, survivorship bias occurs when we pay attention only to the cases that remain visible and ignore the silent cases that did not make it through the filter. You interview successful founders and forget the many failed companies. You study planes that returned from battle and forget the ones that did not. In the quantum case, the filter is conscious presence itself. The only observer who can say "I'm still here" is, unsurprisingly, an observer who is still here. That does not prove anything grand about the structure of fate. It may simply prove that conscious testimony is available only from conscious branches. The thought experiment feels profound because the filtering is built into subjectivity rather than data collection, but the risk of misinterpretation is remarkably similar. There is a moral discomfort here too, and it should not be brushed aside. The logic of the thought experiment is private in a way that ordinary human life is not. Our lives are not lived only from the inside. They are also lived among others, with consequences that extend outward. Any line of reasoning that tempts a person to prioritize their hypothetical, branch local continuity over the reality faced by everyone else is already distorting the ethical picture. Even if some future observer connected to you remains in a surviving branch, that does nothing for the branches in which people around you encounter loss. It does nothing for the public world in which actions have consequences and care matters. The apparent privacy of the argument is part of what makes it philosophically strange, but it is also what makes it so poor a guide to anything practical or wise. Human meaning does not reside only in what one branch local observer later reports. The darker version of the logic also tends to erase the copies, or rather the other successors, in a revealing way. It speaks as though the branch where you continue is the important one, while the branches where closely related observer histories end are treated as if their silence somehow counts for less. But why should it? If many worlds is taken seriously, those branches are no less real. Their observers were no less continuous with your present state before the split. The fact that a surviving branch contains a later voice does not nullify the branches that do not. If anything, the existence of multiple equally valid successors makes the ethical and metaphysical picture more crowded, not less. The dark logic tries to simplify by asking only which branch can still speak in the first person. Reality may be under no obligation to respect that simplification. Another reason the thought experiment remains unsettling is that it reveals something true about how much our sense of self depends on first-person exclusivity. Most of the time, the singular I feels harmless because life appears to deliver one future at a time. Once that assumption is broken, we discover how much of our emotional reasoning was built on it. We want there to be one later observer who is us, one fate that belongs to us, one outcome we can anticipate. Branching denies us that neatness. It offers many successors instead. Quantum suicide then exploits the singular grammar of selfhood against a plural ontology. It says, in effect, wherever any successor still says I, that is where the meaningful future lies. But that may just reflect our attachment to the word, not a deep truth about the physics. There is a final chill in the argument, and it has to do with the difference between the impossibility of experiencing non-existence and the impossibility of non-existence itself. These are not the same thing. You cannot experience your own absence as an ongoing state. That much is built into the concept. But it does not follow that absence is impossible, only that it is never present to awareness when it occurs. Quantum suicide leans heavily on this distinction. It takes the first fact, which is undeniable, and combines it with branching so that the second begins to feel less real from the inside. Yet the larger structure of the universe, if there is such a branching structure, still contains plenty of endings. They are not cancelled because they are not reportable by the one who ended. The silence after a perspective stops is not evidence that it did not stop. It is simply what stopping looks like from nowhere, and that may be the clearest way to understand the dark logic. It is not a proof that you outrun death. It is an argument that first-person awareness, by its nature, only ever appears on the side where awareness still appears. In a branching world, that simple asymmetry can produce the powerful illusion of subjective inevitability. But illusions built from perspective are not the same as laws of nature. The thought experiment teaches us something important about self-location, observer bias, and the limits of first-person evidence. It does not hand us immunity. What it really exposes is how fragile our ordinary language of identity becomes once one present observer can give rise to several futures, some speaking, some silent, all equally real in the wider description. And once you notice that, the next difficulty becomes impossible to avoid, because the whole argument has been quietly treating those other future versions of you as background scenery. It has been focusing on the one who continues speaking and ignoring the others who shared your past just as fully up to the split. But in a branching universe, those unseen successors are not theoretical leftovers. They are central to the question. If there are copies you never get to meet, carrying your memories into different outcomes, then any honest account of you has to make room for them as well. Up to this point, the argument has had a convenient habit of focusing on the one observer who remains available to tell the story. That is part of what gives quantum immortality its eerie pull. It asks you to think from the inside of a branch that still contains you, and once you stay inside that perspective long enough, the rest of the branching structure starts to fade into the background. The silent branches become easy to neglect. The futures you do not inhabit directly, or do not seem to inhabit directly, begin to feel less urgent. But that simplification comes at a cost, because it pushes aside one of the central facts of the many worlds picture. If branching is real, then there are not just survivable futures and non-survivable futures. There are also many other successors of you, carrying your memories, your character, your unfinished concerns, your habits of thought, into branches you will never get to compare from the inside of any one local perspective. That is the real problem of the copies you never get to meet. They are not optional extras. They are not decorative background possibilities. They are the unavoidable consequence of taking branching seriously. Every time the wave function evolves into distinct observer-relative outcomes, the future does not contain one continuation of you, but several, often almost identical at first, then increasingly different as events accumulate. Some of these future versions may live lives that look much like yours would have in a single-world universe. Some may diverge in minor ways, some may diverge radically. The point is that from the present moment, they are all equally descended from the same pre-branch self. They all begin as your future. The fact that each one is trapped in its own local branch and cannot shake hands with the others does not make any of them less real within the theory. This is where the emotional economy of quantum immortality begins to look selective in an awkward way. The argument pays close attention to the future branch in which a continuing observer can still say, "I am here," but it tends to treat the other successors as if they are somehow less central, because they are inaccessible to any one first-person thread. That is philosophically suspicious. If many worlds is supposed to be taken seriously as an account of reality, then the branches you do not get to inhabit from one local viewpoint are still part of reality. The versions of you living in them are still versions of you in the relevant continuity sense. Their existence is not cancelled just because your current perspective will not later include direct awareness of them. In some ways, this is the deepest challenge to the idea of quantum immortality. It reveals that the theory may not really be about one self-escaping death, but about many successors spreading into a branching structure where no single local perspective gets to own the whole future. A simpler case makes the point clearer. Suppose you measure a quantum system with two possible outcomes, and the result is tied to something small and harmless, say which light turns on in a room. In one branch, the blue light turns on. In another branch, the red light turns on. On the branching picture, there are now two future versions of you. Each sees one light. Each remembers walking into the room and waiting for the result. Each feels perfectly ordinary. Each thinks, well, the light came on and here I am. Neither feels copied. Neither feels diluted. Neither feels like a fragment. Both are equally entitled to the shared past. This much already complicates identity, but it remains manageable because nothing especially tragic hangs on the split. Now change the scenario so that the consequences are no longer trivial. One branch contains an observer who continues in one set of conditions. Another contains an observer who continues in a very different set of conditions. Another may contain no observer at all. The branching structure is now emotionally loaded, but the metaphysical structure is the same. There are multiple successors, each with a claim on the past, each occupying their own future. The problem is that when people discuss quantum immortality, they tend to privilege the branch in which a continuing local observer still reports being there, and they start speaking as if that one branch captures the meaningful continuation of the self. But why should it? Why should that particular continuation, merely because it remains available to local awareness, count as the important one while the others recede? Part of the answer is obvious enough. From the inside, you cannot help but care about the branch you're in. Perspective is local, pain is local, memory is local, regret, relief, confusion, all of it is local. A branch local observer does not float above the whole branching structure with equal emotional access to every successor. They occupy one line of experience and not the others. So there is a natural pressure to think of that local continuation as the one that matters. But natural pressure does not automatically produce good metaphysics. It only tells us what it feels like to be one observer among many. The larger theory still insists that the other branches and the other successors exist too. The copies you never get to meet are not philosophical leftovers. They're exactly what the interpretation says reality contains. This creates a problem not just for identity, but for concern. If there are many future versions of you, how should the present you care about them? Ordinary prudence assumes that your current choices affect one future life that will be yours in a singular sense. In a branching picture, current choices may affect many future successors differently. Some will benefit, some will suffer, some may cease. It becomes much harder to speak as though there is one owner of the consequences. In a way, your future becomes morally crowded. The person who benefits in one branch is not more connected to your present self than the person who suffers in another, at least up to the point of branching. They are both your successors. They are both copies you never get to consult. That puts pressure on the whole idea of private subjective escape. Even if one branch preserves a continuing observer, other equally legitimate successors may not be so fortunate. Why should one ongoing local perspective be allowed to dominate the interpretation of what happens to you? This is where the user's topic becomes more philosophical than scientific in the narrow sense. Physics can tell us what sort of branching structure the interpretation implies, or at least what it is supposed to imply. But it does not tell us how to value the successors within that structure. It does not tell us whether identity is one to many, or whether the language of identity breaks down and should be replaced by talk of psychological continuity. It does not tell us whether a later version of you in one branch deserves more concern than a later version in another, simply because one branch happens to be the one from which a surviving local perspective later reports experience. Those are questions about persons, not particles, and the copies you never get to meet sit right at the centre of them. Imagine, for a moment, that branching was somehow visible in a more human-scale way. Imagine that after a quantum event you could actually stand in a hallway and see several future versions of yourself walking into different rooms, each one carrying your memories up to that instant. One looks relieved, one looks worried, one looks distracted by something trivial. One is about to enter a life very much like the one you expected. Another is about to enter one you would have feared. If you could see them all at once, it would become much harder to pretend that only the branch you later occupy matters. You would recognize all of them as yours in some serious sense. Their futures would all look like continuations of the present. The fact that many worlds does not allow you to observe the branching in that theatrical form does not remove the conceptual problem. It only hides it behind the localness of experience. This hiddenness matters because it lets people tell themselves a simpler story. The simpler story says that what matters is whichever branch still contains me. But in a branching ontology, there is no unique future individual entitled to monopolize that word. There are several, and they share your past equally up to the split. The branch you later experience from within is not metaphysically privileged simply because you happen to be in it. It is branch local, not absolute. This is why the copies you never get to meet are so troublesome. They expose the gap between first-person feeling and total description. Locally, you are one observer in one branch. Globally, you may be one ancestor of many successors. Quantum immortality sounds persuasive only when the local feeling is quietly mistaken for the full structure. There is also a practical question hiding underneath all this. Suppose before a branching event, you know that different outcomes will produce different future versions of you. How should you decide what to do now? This is where decision theory enters, and with it the realization that rational action in a branching universe may require you to care about more than one future successor. If all future branches are real, then your choices do not select one world at the expense of the others. They influence the distribution of outcomes across branches. That means prudent action may consist not in ensuring a single good future for one unique self, but in shaping how much of your future branching structure contains good versus bad outcomes. In other words, the copies you never get to meet may still matter to your present choices, because they are part of what your choices produce. That way of thinking stands in quiet tension with the fantasy of subjective immortality. Quantum immortality encourages a very narrow focus on the observer who continues. Decision theory in many worlds pulls in the opposite direction. It encourages taking seriously the full set of successors and the branch weights attached to them. The present self on that view is not merely waiting to discover which local continuation it will feel from within. It is responsible, in some sense, for a whole branching family of futures. Even if no one future observer gets access to the others, the ethical and rational picture may still demand that they all be counted. This begins to make the language of copies feel both apt and misleading. It is apt because there really are multiple future versions sharing the same past. It is misleading because copy suggests a relationship between original and duplicate, and that is not quite what branching gives you. There is no untouched original that continues while inferior duplicates peel off to the side. The present self is not preserved intact in one golden branch, while the others receive secondary status. Instead, the present self is more like a common source from which several equally legitimate continuations emerge. To call the others copies can subtly bias the mind into thinking one of them is somehow the true heir and the rest are imitations. But the branching picture does not support that hierarchy. If anything, it removes it. Still, the phrase captures something emotionally real. The futures you never get to meet do feel like copies in the everyday sense because they are separated from you by more than distance. They are separated by branch structure itself. You cannot compare notes. You cannot comfort them. You cannot apologize to them or ask how things turned out. They carry your past into environments you will never witness from the inside of your own branch. There is something deeply unsettling about that, not only because it multiplies your future, but because it makes that future inaccessible in principle. The alternative lives are not merely hypothetical. They are, in the interpretation, real and unreachable. That combines the intimacy of selfhood with the indifference of physics in a particularly unpleasant way. This also sharpens the question of loss. In an ordinary single-world picture, when one possible future fails to occur, it simply remains unrealized. It may be regrettable, but it never existed. In many worlds, unrealized futures do not vanish in the same clean way. They may occur in other branches. This might sound as though it softens loss, but in many cases it makes it stranger. If one version of you gets something cherished and another does not, there is no unique outcome to settle the matter. Success and failure both exist, distributed across successors who will never meet. The copies you never get to meet make every branch relative joy and disaster feel less final globally and more final locally. From inside a branch, what happens still matters completely. From the total perspective, it is only one thread among many. That duality can be hard to live with intellectually, even before one asks whether it is true. The same issue reaches backward as well as forward. Your present identity may already depend on countless past branchings that produced nearby alternatives to the person you are now. On the many worlds picture, you were never destined to become only this exact version of yourself. There may be innumerable close relatives of your present observer state differing in tiny ways, each equally continuous with a shared past at some earlier point. The self you call me is then not a lone line, but one strand among many neighbouring strands. That does not make your current life less real, but it does make it harder to treat your own branch as the sole owner of your history. The copies you never get to meet may not only be ahead of you, in a sense they have always been alongside you in the broader structure. This is why the problem refuses to stay merely technical. It reshapes how one thinks about responsibility, attachment, fear, and hope. If there are many successes, then fear cannot simply be about one final outcome. Hope cannot simply be about one guaranteed rescue. Attachment cannot simply be to one future self. The branching picture asks whether concern itself should become plural. Should you care now about all the future versions equally connected to you? Should you care in proportion to branch weight? Should you privilege the branches where flourishing is greater? These are not questions the equations answer directly. But once the ontology is plural, the ethics cannot remain comfortably singular, and that in turn reveals what may be most questionable about the popular appeal of quantum immortality. It takes a theory that multiplies successes and quietly turns it into a story about one self-escaping finality. The copies you never get to meet are what that story leaves out. They are the price of the simplification. They are the reminder that branching does not hand one observer a secret tunnel through mortality. It gives one present observer many futures, many of them incompatible, some silent, some speaking, all real if the interpretation is right. The one who continues in your local line of awareness does not cancel the others. It only occupies one place among them. So the real problem is not merely that there are other versions of you out there in inaccessible branches. The real problem is that their existence forces you to ask what you ever meant by you in the first place. If several future people inherit your memories, your structure, your point of departure, and your claim to the past, then why should one of them be the special bearer of your identity, while the others are treated as disposable side effects? Perhaps there is no such special bearer. Perhaps what you call the self is already less like a single possession and more like a pattern that can fan out into multiple continuations. If that is true, then the promise of quantum immortality begins to look less like immortality, and more like a refusal to acknowledge the full cost of branching. And once that cost is admitted, the next step becomes almost unavoidable. Because if the copies you never get to meet are real parts of the theory, then we cannot just ask whether one branch lets you continue. We also have to ask why so many physicists, even those sympathetic to many worlds itself, remain deeply skeptical of the leap from branching to immortality. That is where the idea begins to meet its strongest resistance, not only from common sense, but from the physics community's own discomfort with what the argument is trying to claim. By the time people first hear the idea in its popular form, it can sound almost unreasonably convincing. If reality branches, and if you can only ever experience the branches in which you are still there to experience anything, then surely your own conscious point of view would always seem to continue somewhere. It has that dangerous quality some arguments have, where the sentence is short, the logic appears neat, and the sense of having discovered something profound arrives much sooner than the work of checking it properly. Physicists, on the whole, are not especially reassured by that kind of elegance. They have seen too many beautiful ideas fail. They know that what feels inevitable in a late-night conversation can look much less impressive under daylight and notation. And that is one reason most of them do not sleep particularly well with quantum immortality, even when they are perfectly willing to discuss many worlds itself. The first reason is also the simplest. Quantum immortality is not a prediction of quantum mechanics in the ordinary scientific sense. It is a speculative philosophical consequence that some people think follows if a particular interpretation of quantum mechanics is correct, and if several further assumptions about consciousness and identity are also correct. That is a lot of if for one idea to carry comfortably. Physicists are used to working with theories that make quantitative predictions. They want something that can be checked, something public, something that survives contact with experiment. Quantum immortality, by contrast, lives in a strangely private corner of the discussion. It depends on first-person experience in branches where first-person experience continues. That already makes it difficult to treat like an ordinary physical claim, because science is built around shareable observations, not inaccessible subjective survivorship. Even among those who take many worlds seriously, there is often hesitation at exactly this point. Accepting branching as a way of understanding measurement does not automatically mean accepting any dramatic story about personal continuation. Many worlds itself is already a large conceptual commitment. It says that the universal wave function evolves without collapse, and that branching structures emerge through decoherence. Fine. One can debate that on technical and philosophical grounds. But the moment someone adds, and therefore I never really encounter my own ending, the conversation has moved into a different category of claim. Now it is not only about the ontology of the wave function. It is about what counts as a self, what counts as survival, how consciousness attaches to physical processes, and whether first-person language even behaves properly in a branching universe. Physicists tend to become noticeably less cheerful once the discussion starts requiring that many unresolved problems at the same time. Another major reason for their discomfort is that quantum immortality often sounds much stronger than the underlying theory warrants. Many worlds, whatever one thinks of it, does not tell a single observer, "Do not worry, there will always be a future for you." What it says is that the total quantum state contains multiple branches corresponding to different outcomes. In some of those branches, observers continue. In others, they do not. That is all the formalism gives you directly. The leap to immortality happens only when one reinterprets that branching structure from the inside, and says that awareness must always find itself in the branches where awareness remains possible. But even that sentence is more slippery than it first appears, because awareness is not a free-floating substance in the equations. There is no extra variable labelled the real subject, travelling between branches. There are only branch local observer states. Once that is remembered, the claim stops sounding like a guarantee, and starts sounding like a contested way of talking about multiple successors. This is tied closely to the problem of personal identity, which physicists do not necessarily regard as their favourite responsibility. Many would be perfectly happy if physics could get on with describing reality, without also having to settle what it means to be the same person over time. Unfortunately, quantum immortality drags that issue straight into the centre. If branching produces several future observer versions, each equally continuous with the present one up to the split, then which one is really you? The popular story assumes that any surviving successor is enough to preserve your first-person line, but that may already be too loose. If identity is not simply one to many, then perhaps branching does not preserve a unique self in the way the argument requires. Perhaps it only produces related future observers, each locally ordinary, none uniquely privileged. If so, then quantum immortality may rely less on physics than on a generous definition of survival that not everyone accepts. There is also a deeper issue with probability, and this one matters to physicists because it sits right near the mathematical heart of quantum theory. Any interpretation of quantum mechanics must somehow account for the Born rule, the rule that gives the probabilities of different outcomes. In many worlds, all outcomes occur, so one cannot simply say probability means that one outcome happens and the others do not. One has to explain why branch weights still matter for rational expectation and observed statistics. There are sophisticated attempts to do this, involving decision theory and self-locating uncertainty, and some of them are taken quite seriously. But none of that straightforwardly delivers immortality. In fact, the emphasis on branch weights tends to undermine the popular fantasy. A tiny sliver of branches in which some form of awareness continues does not magically become the whole story, just because that sliver contains a local observer able to say, "I'm still here." From the broader point of view, the overwhelming structure of outcomes still matters, and physicists are usually reluctant to let one observer-centered perspective erase that. This is where the idea starts to resemble a kind of extreme anthropic reasoning, and that makes many scientists wary. Anthropic arguments can be useful when handled carefully. It is perfectly sensible to note that observers can only find themselves in conditions compatible with observers, but such reasoning can also become lazy or circular if it is used to explain too much. Quantum immortality risks exactly that. It says in effect, of course, you only ever observe the branches where you remain an observer. That is true. But from that truth, it tries to extract a much stronger emotional conclusion, namely, that your own conscious experience is somehow insulated from finality. Physicists hear this and tend to notice the gap. A selection effect can explain why certain observations are available. It does not automatically justify metaphysical comfort. The fact that conscious reports come only from conscious branches is not surprising. It may be nothing more than the obvious condition for any report at all. The idea also suffers from a serious evidential problem. Science works best when different observers can compare notes, repeat procedures, and build a common record. Quantum immortality points in almost the opposite direction. If the argument has any force, it does so privately. The observer in a surviving branch can say, from the inside, that experience continued. But that fact is compatible with many different pictures of reality. It does not distinguish many worlds from ordinary chance, because any surviving observer in any framework will still find themselves alive afterward. The branches in which they do not survive are precisely the ones from which no testimony can emerge. That means the apparent evidence is hopelessly filtered. Physicists dislike this kind of setup because it looks like a conceptual machine for generating conviction without publicly discriminating data. The private nature of the argument is not a side issue. It is one of the main reasons the idea remains on the fringes of serious scientific acceptance. Then there is the problem of consciousness itself, which is difficult enough before anyone asks it to carry the weight of immortality. Physics, at present, does not have a settled account of why physical processes give rise to conscious experience in the first place. There are theories, frameworks, philosophical proposals, neuroscientific correlations, and plenty of arguments, but nothing like a universally accepted physical theory of consciousness that slots neatly into the rest of fundamental science. So when quantum immortality says that subjective awareness tracks surviving branches in a special way, physicists often wonder what exactly that statement is supposed to mean. What is doing the tracking? What feature of consciousness makes one branch count as the continuation of a prior observer, rather than merely one of several descendants? If the theory of consciousness is itself uncertain, then building immortality on top of it starts to look like adding a second layer of fog to an already dimly lit room. Some physicists are also suspicious because the idea can invite a misleading picture of branches themselves. In popular discussions, branches are often treated like neat, separate worlds with sharp edges, like books placed on adjacent shelves. The actual technical picture is more subtle. Decoherence gives us effectively autonomous sectors of the wave function, but the precise definition of a branch is not always as tidy as public storytelling suggests. Branches emerge approximately, not as a list of perfectly labelled universes stamped out by a cosmic photocopier. For many purposes, that approximation is enough. It explains why macroscopic worlds appear classical and why interference disappears. But when one begins making extremely sharp claims about personal survival hinging on the existence of some tiny surviving branch, physicists tend to ask how much weight such claims can bear if the underlying branching structure is itself an emergent and somewhat fuzzy way of carving up the total state. The more dramatic the conclusion, the more people want the branch concept to be crisp, and the theory does not always provide that crispness in the popular form people imagine. There is another reason the idea is unwelcome, and it is more psychological than mathematical. Physicists have long experience with the fact that quantum mechanics attracts grand claims from people who are too eager to turn it into a spiritual vending machine. Over the decades, the theory has been used to support all manner of confident nonsense, usually involving consciousness causing reality, minds reshaping the universe, or hidden scientific approval for whatever comforting doctrine happened to be fashionable. As a result, many physicists develop a fairly robust reflex whenever they hear quantum language attached to promises about the self. Quantum immortality, even in its more careful form, walks dangerously close to that territory. It is more sophisticated than the usual misuse, but it still risks sounding like a way of extracting existential reassurance from technical ambiguity. That alone is enough to make many scientists lean back in their chairs. The ethical concern should not be underestimated either. Even when discussed purely as a thought experiment, quantum immortality has an uncomfortable relation to risk. A serious physicist does not want a philosophical speculation to be mistaken for an argument about what is safe, rational, or testable in life. The public world still contains ordinary mortality. Other people still suffer ordinary loss. Any branched local story about continued awareness does nothing to soften those facts. If anything, the idea is dangerous precisely because it is so private. It can tempt a person to privilege the possibility of one surviving observer stream over the full branching reality that includes many outcomes, most of which remain as serious as common sense says they are. Scientists tend to be deeply uneasy with arguments that can be misunderstood in ways that detach private conviction from public consequence. The fact that the theory is not a practical guide is not a footnote. It is central to why it is treated so cautiously. There is also a quiet technical objection that rarely appears in the dramatic versions of the story. Quantum immortality tends to assume a fairly clean link between a branching event and the survival or non-survival of a conscious observer. But real physical systems, especially brains and bodies, are not simple on-off devices. Consciousness is probably not a binary variable that neatly snaps from full presence to absence at a single well-defined boundary in every relevant case. Real lives involve gradients of damage, altered states, confusion, impairment, and slow biological processes. If the argument depends on awareness always finding the branches where it survives, one has to ask what counts as surviving in the first place. Is any residual conscious state enough? What degree of continuity is required? What if the future observer state is deeply degraded? Once those questions are admitted, the clean image of immortality starts to fray. What remains may be only the possibility of some branch relative continuation of experience under conditions that are not at all the ones people hoped the word immortal would suggest. And that leads to another source of unease. Even if a physicist granted, for the sake of argument, that some form of observer relative continuation could persist along surviving branches, that still would not look like a triumph. It would look more like a bizarre artifact of a branching ontology combined with the asymmetry of consciousness. It would not be youth, strength, or safety. It would not resemble the ancient dream of endless life. It might instead amount to the persistence of some ever-narrowing line of awareness through increasingly improbable conditions. That is not a promise most physicists find either plausible or attractive. It feels less like salvation than like a category mistake with unsettling consequences. The social structure of science matters here too. Physicists do not merely evaluate ideas in private. They work inside communities with standards of evidence, habits of caution, and an awareness of which topics are too easy to sensationalize. Quantum immortality is one of those ideas that spreads far more easily in popular culture than in formal physics discussions, because its emotional reward comes too quickly. It tells a story people are already hungry to hear. That is usually a bad sign. In science, the ideas most worth trusting are rarely the ones that arrive pre-fitted to our deepest wishes. They are more often the ones that survive repeated efforts to break them. Quantum immortality has not done that in any conventional way. It persists because it is hard to shake psychologically, not because it has won broad empirical or theoretical consensus. Even those physicists who are friendly to many worlds often prefer to separate the interpretation from the more dramatic personal conclusions that others draw from it. They may say, reasonably enough, that the universal wave function can be taken seriously, that decoherence explains effective branching, and that collapse is unnecessary. But that is still very far from saying that individual subjectivity thereby avoids finality. One can accept the first set of claims while remaining doubtful or openly dismissive about the second. This is important because it shows the disagreement is not simply between cautious, old-fashioned physicists and daring speculative ones. The resistance comes from within the many worlds camp as well. The move from branching to immortality is not built into the interpretation in a clean, unavoidable way. It is an additional philosophical construction, and many people do not think it stands up well. There is finally a reason rooted in scientific temperament itself. Good physicists are often suspicious of arguments that depend too heavily on first-person exceptionalism. The universe, as science has repeatedly taught us, does not usually organize itself around the viewpoint from which we happen to be looking. We are not the center of space. We are not the center of biological creation. We are not the center of cosmic history. And an argument that says, in effect, perhaps your own experience can never really reach its end because you will always find yourself in the surviving branch, can sound like another version of the same old temptation to privilege the observer. Perhaps in this case the privilege is subtler and more technical, but the instinct behind the skepticism is familiar. Physicists tend to distrust conclusions that flatter the perspective of the one asking the question. None of this means the idea is worthless. Quite the opposite. The reason it keeps returning is that it exposes real tensions in how we think about quantum mechanics, probability, identity, and conscious perspective. It is useful because it makes certain hidden assumptions visible. It forces people to ask what they really mean by a self, what counts as a future observer, how much first-person evidence can ever establish, and whether a branching ontology changes the structure of personal expectation. Those are not trivial matters, but usefulness as a philosophical probe is not the same thing as reliability as a doctrine. Most physicists are comfortable leaving it in the first category and refusing the second. So when they do not sleep easy with quantum immortality, it is not because they are unimaginative or allergic to strange ideas. Physics is full of strange ideas. Black holes were strange. Relativity was strange. Quantum mechanics itself is strange enough to keep generations employed and slightly irritated. The problem is that quantum immortality asks for too much confidence in too many contested steps at once, and then presents the result in a form that sounds existentially decisive without being scientifically secure. It is a fragile tower built from an interpretation, a theory of identity, a theory of consciousness, and a very selective use of first-person reasoning. That does not make it boring. It makes it unstable. And once that instability is admitted, the final question becomes harder to avoid, because after all the branching, all the copies, all the private selection effects, and all the physicists clearing their throats uneasily, the basic problem is still sitting there waiting. If the self can branch, if continuity may be plural, and if ending may never be directly encountered from the inside, then what exactly is this thing we keep calling you that seem so determined to survive at all. By the time you get here, after all the branching worlds, all the competing futures, all the observers who survive and the ones who do not, the question stops sounding like a science fiction line and starts sounding almost embarrassingly direct. If you never truly end, what exactly are you? It is the kind of question that can seem either profound or annoying depending on mood, caffeine levels, and whether you have recently tried to explain quantum mechanics to anyone who did not ask. But it is the right question, because the entire idea of quantum immortality depends on it. If the self is a simple, indivisible thing, a single thread running through time like a bead on a wire, then branching looks like a problem or a contradiction. If the self is something looser, something more like a pattern that can continue in multiple ways, then the idea becomes less contradictory and more unsettling. Either way, we cannot talk about surviving forever in some branch unless we know what the word you is doing in that sentence. In everyday life, we act as though the answer is obvious. You are the same person who woke up this morning, the same person who had lunch, the same person who now finds themselves listening to or reading this and wondering whether the universe is perhaps a little too creative with continuity. You have a name, a body, a memory history, a recognizable style of thought. Other people identify you across time and you identify yourself. The world is not constantly asking you to prove you are still you, which is just as well because most of us are tired enough already. Identity, in practice, works. That is one reason we rarely inspect it too closely. Functional things are often left alone until they begin making philosophical trouble. But if you do inspect it, the first thing you notice is that the self is not nearly as solid as it feels. You change constantly. Your body changes. Your beliefs change. Your memories fade and rearrange themselves. Your preferences shift. Your voice changes over the years. Your face changes. Your priorities change. There are versions of you from the past who would not entirely understand the present one, and there will probably be future versions who find the current you charming, naive, irritating, or all three at once. And yet through all of that, identity remains good enough for life. Why? Not because there is perfect sameness, but because there is continuity. One state leads into another. Memory overlaps. Personality overlaps. The organism persists. The later person inherits enough of the earlier person that we treat them as one life. That is already an important clue. The self may not be a thing in the way a stone is a thing. It may be more like an organized process, a dynamic structure that carries information forward through time. A storm is not made of the same exact droplets from one moment to the next, but it is still the same storm in a meaningful sense because the pattern persists. A flame is not composed of fixed matter, but it remains identifiable because the process continues. Human beings are not exactly storms or flames, thankfully, because neither usually has to answer emails, but the point stands. Some things remain themselves not by staying materially identical, but by preserving structure and continuity through change. If that is what a self is, then the self has always been less like a nugget and more like a pattern. Once that idea is allowed in, branching becomes easier to state and harder to emotionally resist. A pattern can have more than one continuation. Not every pattern can, and not every continuation deserves to count as the same thing for every purpose. But in principle, a structure can split into multiple later structures that each preserve important features of the original. If you copied a text file, there would be two identical continuations of the same informational pattern. If you grew a cutting from a plant, there would be a continuation of biological structure. If the future observer state produced by a branching event preserves your memories, your character, your causal history up to the split, then it begins to look less absurd to say that the self has continued in more than one place. Strange, yes. Offensive to common sense, certainly, but not incoherent. This is why the most careful response to the question, "What are you?" may not be a soul, a body, or even a mind in the simple everyday sense. It may be something like this. You're an ongoing informational and biological process that produces a first-person perspective. That sounds colder than people usually prefer. It also sounds like the sort of line one could deliver very confidently at a party, and then spend the rest of the evening standing alone near the snacks. But it captures something important. What matters for a self is not perfect material sameness. It is the organised continuation of a perspective-bearing process. That is why you survive sleep, survive distraction, survive forgetting most of Tuesday, and survive gradual bodily change. The pattern remains continuous enough to count. If so, then the idea of never truly ending becomes both less magical and less comforting. It becomes less magical because nothing supernatural is required. No ghostly essence needs to hover over the branches picking a destination. No hidden pearl of identity needs to shine unchanged beneath all physical events. The continuation of the self would simply be the continuation of the pattern in those branches where the relevant structure persists. But it also becomes less comforting because a pattern is not the sort of thing that demands uniqueness. A pattern can branch. A pattern can degrade. A pattern can continue in forms that are technically related and emotionally unsatisfying. If immortality belongs to a pattern rather than a sacred singular thread, then it may not resemble the personal fantasy people imagine when they hear the word forever. This is one of the places where philosophy becomes annoyingly useful. Derek Parfit, among others, argued that personal identity might matter less than we think, and that what really matters is psychological connectedness and continuity. You do not need a mysterious extra fact beyond continuity for survival to be meaningful. If a future being remembers your life, carries your projects, inherits your mind in the relevant ways, that may be enough. In branching cases, there may be more than one such being. That does not force us to say one is fake and one is real. It may simply force us to admit that our old picture of identity was too narrow. The self may be a relation across time, not a little monarch seated behind the eyes. That becomes especially important in a many worlds context because the theory does not preserve a single royal road into the future. It preserves a branching tree of successor states. If you insist that there must still be one uniquely real future you, then the interpretation will always feel impossible. If instead you allow that the present self can give rise to several equally legitimate future continuations, then the problem changes shape. The question is no longer which one is the real you. The question becomes whether the word real is doing any useful work there at all. Perhaps all the successors are real. Perhaps your present self is simply the common past of several later selves, each of whom is locally ordinary and globally only one part of the full structure. Now, of course, most people do not want to hear that they are a branching informational process with multiple possible continuations. They want to hear that they are themselves, entirely fair. But notice that the branching picture does not erase that feeling from the inside. Every local observer still experiences life as singular. Every branch-specific version of you wakes up as one person in one world with one set of memories. The self does not feel plural from the inside, even if the ontology is plural from the outside. That is one reason the idea is so slippery. Subjectivity remains local and normal. Multiplicity exists in the total description, not in the texture of everyday awareness. So when we ask what you are, the answer may differ depending on where the question is asked. From inside a branch, you are a single ongoing person. From outside the branching structure, you may be a family of related continuations sharing one past. This also clarifies why the idea of never truly ending can sound more dramatic than it deserves. If you are a pattern, and if that pattern continues somewhere in the branching structure, then in one sense you do not end absolutely. There are later states related to you strongly enough to count as continuations, but if you are looking for one indivisible inner witness that remains untouched and singular across all futures, the theory does not really provide that. It gives you continuity without uniqueness, and that distinction is everything. People hear the first half and imagine salvation. They miss the second half and forget that what continues may no longer fit the emotional picture they wanted preserved. There is another complication. Even in a non-branching world, the self is already stranger than it feels. Every day you pass through altered states. You are drowsy, focused, distracted, numb, excited, absent-minded, absorbed, exhausted. The self is not a fixed crystal. It is a shifting organisation. There is enough stability to hold a life together, but not the perfect stillness our language sometimes suggests. Memory, especially, is an imperfect glue. We do not remember our early infancy. Much of childhood is fragmentary. Ordinary days disappear with alarming efficiency, and yet we still count the whole thing as one life. That means identity has always tolerated gaps, distortions, reconstruction, and gradual replacement. We were never as metaphysically tidy as we like to think. Quantum immortality takes advantage of that flexibility, though perhaps more than it has a right to. It says, in effect, if you already accept continuity through change, sleep, forgetting, and bodily turnover, why not also continuity through branching, at least along surviving lines? It is a fair question. But it is only fair up to a point because branching adds competition. In the ordinary case, there is one main future observer to inherit your life. In the branching case, there are several. That is why the concept strains. It is not continuation alone that causes trouble. It is multiple continuation. The self, if it is a pattern, may survive pluralization better than common sense expected. But pluralization still changes what survival means. Perhaps the simplest way to put it is this. You are not a point, you are a trajectory. More exactly, you are a trajectory capable, in the right theoretical framework, of fanning out into several later trajectories. Each later one remains locally centered. Each later one says, I. Each later one has enough of your history to count as your continuation. None of them contains the whole story anymore. Once the branching has happened, there is no single future location where all of you resides. There are only several descendants of the present perspective. If one of them later wonders whether they are the original, the answer may be that the question no longer applies in the way they hoped. That sounds abstract until you return to the emotional core of it. What exactly are you if you never truly end? Maybe you are not the sort of thing that ends cleanly in the first place. Maybe the demand for a sharp boundary around the self was always partly a convenience. We need it for law, for social life, for memory, for planning, for moral accountability. But at the deepest level, the self may be a gradually changing, physically implemented perspectival process. Processes do not always stop in a single philosophically satisfying snap. They thin out, split, continue, or terminate depending on the structure that sustains them. If quantum branching is real, then the self may be more like one of those processes than like a sealed container. Still, there is a danger in getting too comfortable with that answer. One can begin to speak as though the self is just a pattern, with the word just doing the sort of dismissive work it so often does. But a pattern that feels, remembers, suffers, hopes, and inhabits. A point of view is not a trivial thing. Calling it a pattern does not make it less serious. In fact, it may make it more serious, because patterns can be vulnerable in ways that solid imagined essences are not. They depend on structure, they depend on embodiment, they depend on continuity being maintained by real physical processes. If you are a pattern, then what matters is not some hidden immortal core, but the actual conditions under which the pattern continues well or poorly. That should make us more careful, not less. And that may be the quiet lesson buried underneath the whole strange discussion. Quantum immortality is fascinating because it takes our fear of ending and places it inside a theory where outcomes branch instead of collapse. But the deeper result is not that you have been granted a loophole. The deeper result is that the self may already be a more distributed, less singular, more process-like thing than everyday intuition admits. If there is any sense in which you never truly end, it is probably not because one untouched inner subject travels forever. It is because continuity itself is a richer and less singular relation than the old story allowed. Some part of what you are may keep going in those branches where your structure keeps going. But that is not the same as saying you, in the simple childhood sense of one hidden somebody behind the face, have outwitted mortality. At the same time, the discussion should not leave us with a flat, joyless reduction either. People sometimes react to this kind of philosophy by saying, well, then nothing matters. The self is an illusion. We're all just temporary arrangements. How dreary. But that is not really the right lesson. Temporary arrangements can matter enormously. Music is an arrangement in time. A conversation is an arrangement in time. A life is an arrangement in time. The fact that something depends on structure rather than metaphysical simplicity does not make it empty. If anything, it makes it more precious. A living self is not less meaningful because it is made and maintained rather than handed down as an indivisible object. It is meaningful precisely because it is a real, fragile, ongoing organisation of experience in the world. That is why the final answer to our question may be a little plainer than expected. What are you? You are the organised continuation of a conscious life. You are memory held together by a body. You are a point of view built by a physical process. You are one present centre in a reality that may be more crowded with other centres, and even other continuations of yourself than common sense likes to imagine. If many worlds is right, then you may not possess one exclusive future. You may possess many successors. If so, then never truly ending would mean not that one magical self escapes everything, but that the pattern which is you may continue wherever its conditions of continuation still hold. That answer leaves us with less romance and more honesty. It also leaves us with something unexpectedly practical. If the self is not a sealed jewel but a living process, then what matters now is how that process is shaped. How you think, what you do, how you treat other people, what sort of future structures you help bring about. These things matter because they are the substance of the pattern itself. The meaning of a life does not wait at the far end for a final metaphysical verdict. It is built in the continuity. It is built in what gets carried forward, whether in one ordinary future or if the universe is stranger than it looks in many. And perhaps that is the gentlest way to leave the whole question. You may not be a single unbreakable line. You may be something more flexible, more distributed and more difficult to summarize. The universe may not guarantee you the kind of immortality stories usually promise, but it may also be the case that ending is not quite as simple as we once thought, because the self was never as simple as we once thought. If there is a comfort here, it is not the comfort of being untouchable. It is the quieter comfort of understanding that the thing you are trying to protect was never a tiny isolated spark trapped inside matter. It was always a living continuity, held in a body moving through time, becoming itself moment by moment. So wherever you are listening from, at whatever hour it happens to be there, perhaps the most useful thought is not that you have escaped death through a loophole in physics. It is that being a self at all is already stranger, deeper, and more interesting than the ordinary daytime version of reality admits. And for tonight, that may be enough to sit with.